Yes. Hey, welcome everybody. This is the monthly meeting of the Robotic Society of Southern California. My name is Ben Partida. I am the current president. I am here with all of my officers and members online and in person. Thank you for joining. Today we have two talks. The first speaker we're gonna have is Alan Tim, who is going to tell us his progress with his Go2 robot dog and his project where he's gonna add a head and neck mechanism to it. Pretty cool. After that, we're gonna have Jim, who's gonna tell us about his progress with his Truckosaurus, a fully autonomous vehicle that is being built for the Robo Magellan contest. After that, we're gonna do show and tell, and then we're gonna break for lunch. And wait, show and tell first.
30-minute show and tell.
30-minute lunch, and then show and tell.
Yeah. Hard stop. 30-minute lunch. Grab and go, and then announcements and show and tell. And we're going to insert a 10-minute break in between each of our talks to stretch related or do whatnot. We're going to try really hard to wrap it up at 15 minutes still. So we'll try it on for size and see how it works.
All right. So I will give you guys a 5-minute warning at 40 minutes.
About 10 minutes, 5 minutes.
10 minutes and 5 minutes? Yeah. Okay.
Perfect.
So I'll do a 10-minute warning at 35 minutes, then another one at 40 minutes.
If you miss your deadline, pour cold water on you.
Okay. That's Danny's job to pour water.
Yeah.
Not the robot, just me, right?
The robot didn't do anything wrong.
Morning.
Good morning. Come on in.
Good stuff.
You need a squirt gun, Ben.
You can up there. Is anyone?
Yeah, come on in.
I did.
Nice.
What did we name them last time? I said I'm going to next time.
All right.
Excellent.
Awesome. All right, let's get started. Alan, take it away.
All right. Good morning, everyone. Let me go ahead and share my screen here. There we go. There. Rearranging some things on my side. We are not starting with source code or anything. Don't worry about that. We're going to start gently with. I put on my window. So, like most things in my hobby, my current direction started on a whim. There's a Discord of Go2 robot hackers, and one of them, and I should have grabbed a photo of it, 3D prints different heads and tails for it. Very whimsical, a lot of fun with an LED light panel up on front. And one of the members jokingly suggested maybe he should do the head from the K9 unit from the Code Red Part 2 movie. It's a Netflix movie. I'm not going to show a preview. There's a little bit of violence and some adult things, but the robot design is super cool. And a few weeks ago, I posted the art station of the guy that created the design for the movie. And you know, instead of doing something productive, why don't I see if I can do that? So the first challenge is to figure out what that neck design is. So it looks familiar. I know I've seen it before. Let me get a little bit of a close up here. So there's 6 pistons arranged in a certain orientation, and after a little bit of Googling, it looks a little bit like a motion controller platform. Quickly figured out that the name of that platform is a Stewart platform. There are 6 litter actuators arranged in, they can be in a V or a triangle configuration, or really anything. So after figuring out what it was and that it already existed, so I probably wouldn't have to come up with any control things from scratch. The next step was to figure out how to design one. And let me show a quick video. This video is old, but it's still really cool. He has 12 servos. 6 are set up as active and 6 are set up as passive. And then he can attach the control stick, and he's just taking the output from the right and feeding it into the positions on the left. So with the Stewart platform, it's capable of translation and rotation in all 3 axes. So depending on how they're set up, it can be really expressive. All right. So, I think we're onto something. And as it turns out, the fully developed Stewart platform has 6 linear actuators and is capable of 3 rotation and 3 translation. If you knock it down to 3 servos, it's called a 3 degree of freedom Stewart platform, and is capable of translation in all 3 axes, and still is usually capable of rotation in 2 axes. I may revisit that in some point, but I just thought the 6 axis was cooler. So that's what I ended up going with. Ben's gonna pop some links into the chat as we go through this. I have an album set up. So on my desk right now is a prototype of the neck and head on a platform. I happen to think it looks super cool. And I need to finish the design of the head because there's some ducting for the fan and a few more attachment points. But it uses an off-the-shelf RGBW light assembly, so I didn't have to do that. An OP light. There is a servo in the head to give me a greater pan. I can usually actually pan up to 360 if I wanted to. And then a 40 millimeter case fan, a 12 volt fan that'll blow air across the OP light and down. The material I'm using for this is a carbon fiber infused PETG. It's an amazing material. I think it has the perfect combination of bendability and stiffness, even though that sounds contradictory. I've got a couple of samples down on the table that I can share. And the surface finish on it is really, really cool. I'm printing it with 100 micron layers. So to the naked eye, you can still see them in bright light, but it just has a really cool, slightly irregular surface finish that I think will work really well with this project. So one of the first steps, aside from getting your hands dirty in Fusion 360 and getting the design done, is to figure out which servos you're going to use. One of these is a servo. Oh, maybe I didn't share it. That's okay. And so the servos I ended up using, serial bus servos, of course, where, for the most of us, hopefully now we've pretty much grown out of the traditional PWM servos. So you get temperature feedback, you can set acceleration and torque curves, and they're darn near 360 degree. And the ones that were shallowest, meaning I could pack them in the tightest triangle possible, are these imitation Dynamixel servos. The ones that actually are used on my Alfie robot that we talked about a few months ago. Now the $20 servos are perfectly acceptable. In an earlier iteration, I thought I needed the brackets that were only included in the $50 variant that has an aluminum case. They're the exact same servo. It just one has a plastic case and one has an aluminum case. And it so happens that the aluminum case version comes with comes with one of the brackets that I needed that you'll see that I used on here. So one of the good things, bad things about these is they're already set up with screw holes for mounting. The challenge is that those screws are, and I've never included enough photos, are like 1.5 millimeter machine screws, which are great for mounting. But this head is going to be mounted on my robot, and my robot tends to fall. It's a quadruped, it walks, it stumbles, it trips. And the other guy that 3D prints heads is already figured out. He attaches them with TPU so that when they fall, the head will separate from the TPU and then nothing gets destroyed. So with that kind of an application, 1.5 or 1.8 millimeter screws are not really going to cut it. So even though I've used them and the brackets on here, I'm coming up with a plan B to attach them in a way that doesn't make it impossible to recover when 1.8 millimeter screws break. That's the end of the road. Oh,
Kind of creepy.
Roger is lurking in the background. What about me, Roger? So one of the things that I figured out is that instead of mounting the servos to anything, and this is the rotational servo that's mounted in the base of the head, I'm using what I'm terming a servo capture system. That if I can hold the servo down in all 3 dimensions, so we've got 1 dimension that way and 1 dimension this way, and then it switch over to the model here. Let me get rid of the neck assembly and the base. It actually screws in to the base unit right here, which captures it in the 3rd dimension. So this way, it is firmly secured. And yeah, there might be a ½ degree of wiggle room or something. It's not, this whole thing isn't precision. But now there's a fighting chance of, you know, I won't just break screws the first time it takes a fall. So while in the prototype on the base, I'm using those brackets just temporarily. When it connects to the robot head, and I'm redesigning the head shell right here, it'll use a similar capture system to hold in the servos without any screws. If the plastic breaks, I can print out a new one. But if I snap out screws in a $50 or even a $20 servo, chances are I'm not going to be able to dig them out. So this going over, you know, the list of design considerations to breathe life into this. Capture system for the servos, don't use the 1.8 millimeter screws. If you break plastic, you can always reprint it. The next challenge is precision. So these servo rods, and there's 6 of them. So I've got a little cover just for aesthetics, and then 16 millimeter M4 threaded rod right out of Amazon. 4 M4 tie rod ends, aluminum, straight off of Amazon. And after a little searching, I finally decided which servo arm to get. Again, Amazon, most of them were next day delivery. You want them all to have the same length. And so aside from whether or not you're putting tension on the rod ends or not, the thread pitch, standard thread pitch on M4 is 0.7 millimeters or 700 microns if you prefer not to think in fractions, which means that for every half turn, you're advancing or shortening the whole assembly by 350 microns. That is perfectly fine, right? Because with every twist, you want to make sure that the flat sections match. So a half turn, 350 microns, I can definitely live with those tolerances. So what you want to do is to design and print out a quick jig that has the final dimensions that you want. And then as you're setting up, and this is the pictures of the longer one, the new ones are about 20 millimeters shorter. You set it up and then you twist it by a half turn, and then you set it on until it easily comes on and off the 2 posts. So using the jig, I was able to get all 6 of those arms within 350 microns or so of being the same. Now, if your precision is to your heart, this isn't probably still enough, and I don't know what other things are, but for this application, it means that they're all the same.
I think servo arms, don't they have ones with like male, female screws so you can twist the screw? I think that's how the RC cars do it.
Yeah, oh yeah, they'll usually have a nut. So you'll get it to the right length, and then you'll tighten the nut between the rod end.
No, so you're limited to like a half turn at a time,
Yeah.
right? I think you have like a male version at the end and a female version at the end, and you move the screw and the whole thing just kind of.
Oh,
Let me look at my car. I think that's how it works.
okay. Yeah, no, yeah, I'd love to take a look at it. For now, this would great, but I'm always looking for looking for new options for sure. This is new territory.
Right.
No, go ahead.
All right, the next jig that I did was the serial bus servos. Their dead zone is usually about 1/7 of a degree, so they're very accurate compared to PWM servos. But still, out of the box, when you attach the servo horn, you want 90 degrees to be 90 degrees as close as possible. So I designed and 3D printed a jig that fits up flush against the servos and holds the servo arm exactly 90 degrees. And so when you go in and you program the servos, there are certain settings that are wiped out after every power loss and some that are saved in EEPROM. The offset is saved between power ups. So you will tune that offset so that 90 degrees is exactly flat for the jig. And so you do that for all 6. And now those are as accurate as you can get without, professional engineering machine. The last engineering trick that I did was on the Go2, they use these inset nuts to firmly affix things. If you're assembling a robot and you're only going to assemble it once, use wood screws, and they'll survive a couple of screws and unscrewing, so to speak. For anything where you want some durability to screw and unscrew, you'll use machine screws. And this is my first time using heat inset capture nuts to make it a little more durable. Now, Ben insists that I've used these before. I can't remember doing that, but that doesn't mean that I haven't forgotten, which is entirely possible. And actually, I got a bunch of stuff to pass around. You can buy these kits for like $12. And as long as you guys don't open it, if you do, you're throwing them all back into their bin. And it was super easy. You just warm up your soldering iron, you line them up, and very quickly, brass being what it is, it warms up and it melts right in.
So this goes inside there, and then it provides a firm base to screw something else
So then it screws in.
Cool.
So a little bit more durability. So I was excited to. Yeah, I was excited to do that. Yeah, that kit has M2 and 3, I think M4. But enough to keep me.
Just you apply the soldering iron for like 20 seconds.
Yeah, you set it up against the hole, and then you put the hot soldering iron against it, and within about 5 seconds, it starts to sink in.
Oh, I see.
Yeah. So depending on how you define precision, is the hole going within 50 microns of where you 3D printed it? There's some variability in there, and that's one of the main challenges of this is that when you're designing things in 3D, right? So you've got your neck assembly and your head, and you're assembling this. This assembly is accurate to 8 decimal points, right? Like the virtual one, and when you're in simulation, everything is accurate to float 32 or float 64. The real world isn't really that precise. The real world is messy. So anything you can do to close that gap will help the end product. And in a case like this, where you have 6 turbos that all need to move in unison and be in about the right spot, taking a few minutes to get these as accurate as possible will really, really help.
Will hole diameter depend on your material for these?
The M3 folding nuts have an exterior starting dimension of 4.2 millimeters. So you do a 4.2 millimeter hole, and it kind of sets a little bit in there, and then as it sinks in, the little legs catch and yeah. So the last design consideration for this is these servos are, according to the manufacturer, rated for 30 kilogram centimeters. That is way, way overpowered for this application. But they are the smallest ones that fit. There are weaker servos, but they were a little bit deeper, which meant that the base would be wider. And I'm trying to aesthetically have it fit in with the bot. So what that means is that any errant command or problem with programming could tear the neck assembly apart. In addition, while the threaded rods are M4 or 4 millimeter, all the connection points are M3. So yeah.
6 degrees of freedom. Does that mean I can move any one servo and the neck will respond somehow, or is it gonna fight?
They all need to coordinate. Yeah, in the 3-axis variant, you can move any single servo and it'll adjust. But now, because realistically there's 4 active, 2 passive, and the 2 passive have to match the same.
Okay, that's what I thought. So you've got to get it perfect or else they're fighting each other.
Yeah. Yeah, and the other part is there is a torque limiting function in these servos. You can say, provide torque up to some function, but it's a high gear ratio serial bus servo with a lot of inertia.
You can just snap stuff.
And so if you set it too low, it takes too long to get there because it's self-limiting itself, because there's still a lot of torque to get the entire gear train. All right. So after a couple of weeks of spending every waking moment after hours designing and printing this, the next step was to figure out how to control it. Now, because through an earlier Google sleuthing, I figured out that this was an existing thing, and hoping that I wouldn't have to write the code from scratch. I had a rough idea of the control methodology for it, but let's be honest, there's only so many hours in a day. And if someone else has solved it, let's use that. So a quick search for Stewart platform Arduino code. Produced a couple of code bases that I started to convert, and then I'm like, why am I doing this? Why would I look for that? Because my proof of concept is all in Python. So updating my search brought me to someone way smarter than me that's already put in the effort to not write not only the code, but also a notebook library that you could use to play with it. The code is very easy to follow. It's parameterized, so you can put in the characteristics of your Stewart platform, and then it just solves for it, which is absolutely perfect. So let's talk for a moment about what this control looks like. Let me go ahead and bring this up in another window. So, all right, this is just going to float around a little bit. In robotics, when you're talking about how to control like an effector or an arm or a hand or a finger, we talk about 2 different control methods. One of them is called forward kinematics, which is the easiest, right? So you know the length of each digit in your finger, you know what kind of joint it is, and a little bit of trig and 3D math. And if you know the positions of all the joints and the lengths of all of your digits, you can calculate out the position of the tip of the finger, right? So that's called forward kinematics. It's robotics 101. For robot arms, the hard part is the inverse kinematic solver, right? Figuring out if you want your hand, your tip of your finger here, what are the legal positions of the joints to produce that, right? And it's non-trivial. There are a bunch of packages available in Ross and other ones, and it's a lot of frustrating / fun. Now, this Stewart platform you could consider to be an effector. You have all these joint inputs, and that produces some type of output or position on the top. Now, what you see on the top in green, that's called the platform. That's what you're moving. And then in blue, down below, is your base. And there's a couple of parameters that define circumference of the circle that's circumscribed by the points and the angle between the contact points. Now, it turns out with the Stewart platform, the forward kinematic solution, the one that's super easy for arms, is non-trivial. It is very difficult. Or let's just say I haven't seen a solution for it and can't figure it out. To say if you know the positions of all 6 arms, what the position of the platform on top is. And so continuing the theme of opposite day, the inverse kinematic solution for this, where you put your platform in a certain position, now calculate out the positions of the servos to achieve that, is actually really straightforward. Let me see if I can enhance this a little bit. And you're not going to stop moving, are you? Oh, because you're a GIF. All right. So as you can see, each connection point is being modeled as a triangle. Now that part in yellow that keeps flipping around fast, that part in yellow is the virtual linear actuator from a standard Stewart platform. And I think I found some small enough linear actuators to actually use, but I don't know, they're like $80 a piece and I'm not made of money. So I went with the servo version, right? So each of the yellows is considered a virtual linear actuator. Now, the parts in black and in red, those are the actual physical parts of. Let's make its way around. Okay. Going past part. Can't help you pass around, doesn't it? There's no right being on the dog. Yeah, sorry about that. Are the 2 arms of each of the actuator assemblies, right? So, and if you want to figure out the positions of the actuators, and you know the positions of the attachment points in the platform, if you can imagine a function that has 3 translation offsets and 3 rotation offsets, you can calculate the resulting position of each of the attachment points on the platform in green. And then it's pretty much just trig to figure out the angle of the servo that will result in that yellow virtual linear actuator link. So I had a game plan in place, perfectly happy using someone else's code. And so knowing that, you would imagine a function where you define those 3. You probably put in some safeties, like for the raw positions of, here, let's switch back over. Of each of the servos, like maximally, you don't want to max it out at a full 180 degrees, so maybe 85 degrees, just so you don't lock. And then going down, it goes down to about 65 degrees. So as part of your function, you're going to make sure that there's no command position that results in exceeding those. And if it exceeds it, you reject it. But there's another trick to it as well that's also non-trivial. In some other implementations, you'll see some like, maximum 20 degrees fore and aft, left and right, up and down, and then maybe a maximum 15 degrees in rotation in each one. But the truth of the motion limits is a lot more complicated. And unfortunately, one of the things that's complicating it is the attachment point. So these are more or less spherical attachment joints, but they're not only limited by, in this case, this is coming up right against there. And so how do you calculate that based on your translation and rotation command? Because that's going to change for every position. But also the tie rod ends themselves are limited to about, looks like maybe 10 degrees. And so I'm looking for something better, but for right now, you have all of these limits that you can't really program in because it depends on the geometry. So there's some naive solutions that just put limits on rotation and translation to get you in the ballpark. Maybe you can monitor the current uses in the servos to see if you've exceeded. But Practically, I can't think of any other way of managing this long-term than a reinforcement learning solution that has the kinematic model of it into account. Because it's going to be tricky. I am looking for ways of increasing the range of motion. As of right now, I don't even see. I see it can't even go that far forward because look, we already have interference there. So from here, maybe an inch forward, an inch back. It should be able to go about 5. Sorry, it's a 20, so 10 millimeters down, and max 18 millimeters up. So it's still going to be expressive, which is great. And then if you, so I have put some limits in it, but if you exceed those, as the inverse kinematic solver tries to solve, you get weird stuff. So don't do that. Go back a little bit. So yeah, hardware wise, we're almost done except for the head. The next steps are to rework the panel to attach it to the neck. But before I do that, I need to find a programming solution that takes into account the head and the neck. Now, over the past 6 months, there's been a lot of activity in the quadruped space, specifically for the Go2 robot. I've seen at least 6 and maybe even 12 total, including the Go1 reinforcement learning projects for motion planning. There was a recent project where they did full body reinforcement learning motion control, taking into account the command position for the gripper. And in my opinion, control strategy for the robot and the head would have to be like that. So just like any biological organism, your movement is most often driven by head position. So as soon as I see an interesting development in that, that's when I'll probably attach the head and take a crack at it. And until then, I've got a lot of work to do with it, just sitting on a platform. So yeah, getting back over to the model. I'll continue plugging away on this. Depending on which one of us wants to take the 10 a.m. slot, there'll be another update next month or the month after. The other half of this is the guy that inspired me to work on this. He does robot dogs with passive tails. I had envisioned making a 2 degree of freedom tentacle style tail, because if you have a dog with a head that can't wag its tail, is it really a dog? And then I remembered that there's versions of quadrupeds that have arms built into them. So just as a placeholder, I took a copy of the arm model from my Alki platform and stuck it on just to take a look at it. I won't use this arm as is on it. There's a bunch of things I would need to change. But the reason I'll probably do this next is there's no reason I can't rearrange the joints on the arm so that the hand can wave like a tail when you're not using it, using it as an arm. But the Boston Dynamics arm is when the effector is attached, you know, have your Visa or MasterCard handy. It's attached in front, and at rest position, the hand looks just like a face, which is awesome. In the Unitree versions, as well as the Go2 version, if you want to spend $10,000 on the arm after you spend, you know, $15,000 or $20,000 on the EDU version of the robot, which I don't have that kind of money, it's mounted backwards. So with this type, it wouldn't be able to reach very far in front of it. So this isn't a solution where you could grab something on the floor in front of you, but to the side. And I guess maybe even backwards. I'm guessing to be useful, there would need to be a camera attached, just because without that, there's not enough information from all of your sensors, which are traditionally forward facing, to be able to make the arm useful. But until I figure that out, I'll have a hand that can wave like a tail, which I think will be pretty cool. The highly accurate step file of the Go2 that I have that I used as the basis for the highly detailed visual representation of the robot in Omniverse for simulation. The shells are accurate, but it doesn't have all the internal attachment points and stuff. So I've been doing a fair amount of work to, let's see if I can find it. There we go. To reverse engineer replacement top shell. So if they have the right shape, it's just a matter of adding the attachment points and printing it out. So I have a failed version of that shell print here that we can pass around. This is also done in a carbon fiber infused PETG. This one was in black just because it was the stuff I had on hand.
So this you can't.
I mean, you could, but yeah, it'll bend a lot more than before it snaps. Now this is a failed print. Let me go ahead and I think I have a copy of it on screen for those of you tuning in from home. Now there are like a copy piece. Interesting. So this print failed in 3 different ways, and I love having successful prints, but there was a lot that I picked up from this. This was printed with this piece on the bottom and then printing it straight up. Again, the carbon fiber infused PETG has this really neat surface quality. I love it. It failed in 3 different ways. The first way that you can't see here, but I'll walk you through it, is it's being printed in an enclosed printer with an 80 degrees Celsius build plate, which means that the build volume was approaching 80 degrees Celsius. Great to reduce warping and get even better 3D prints. But at that temperature, PETG starts to become pliant or more bendy. And so as the print head got higher and higher, the whole print started to flex because of the friction of the print head laying down plastic up on top, which caused this, and eventually I stopped the print. So it's not even at the full height. So I don't think that'll be a problem on the final print because there will be a lot more structure to print, and so it won't be quite as flimsy. The next piece is, and it's pretty easy to see here, you can see these kind of reflections or what we call ghosting that seem to match some contours of the print. I printed this one as fast as I could because my printer can do that, but I'm still limited to physics and the hardware. And at faster print speeds, you'll actually get a resonance as it commands to go to a certain position, the print head does, but there's inertia and there's mass, and it ends up vibrating a little bit or resonating. So what you're seeing is the echoes of sudden direction changes being seen on the surface of the print. It's very subtle. You probably can't even, well, maybe you can feel the ridges with your fingers, but they're visible to the naked eye. So I slowed down the exterior perimeter speed a lot for all the prints for the head and the neck, and so now that's not present. It ends up printing about 85% as fast as the proverbial next to the wall speed that I was printing at, but you get a much nicer surface finish. So it's a trade-off I would gladly make. Let's see. I think this is the first time I finished early. So just to recap, next steps: get the code working. I tried so hard to have working code on the physical hardware last night. But the output of the Python code stewart platform function, it's doing everything right, because in the simulation in the matplot live, the visuals, it looks good, but the resulting angles that I'm getting out of it don't match what I'm seeing in the model. So I have some more troubleshooting to do. And I'm like, man, we're doing all this for fun. So I'll continue working on it, and this will give me more than enough to talk about in upcoming months. So the next steps are get it working on hardware, keep an eye out for whole body motion control strategies with a head instead of an arm. And then once I find something cool, attach it and then start working on a custom arm design for the robot, just so I have something to wag when the robot's happy.
So can you talk a little bit about how you plan to integrate this with your robot? So like, where's the power coming from? Where's the control coming from? I saw that second picture, you had another box on top that probably is another compute unit. But like, who initiates control? Is it going to come from the internal computer and then emanate out, or are you going to have another control box on top?
Yeah. So for those of you who aren't already aware, I'm not the only go-to owner in the audience anymore, which I'm very excited about. There might actually be a third.
You're not an owner, but he's a.
Oh, perfect. Okay, so yeah, we've got 3 pilots, and I've got Jim on the fence about it. I'm trying to instill the FOMO into him. I've got a pretty good start. Now it's a closed platform unless you spend $50,000 for their EDU version, which I did not do. The air version or the radio control version is $1,600, but if you include shipping and handling in the price, which they should, $2,000. So not cheap, but you get a lot of hardware for the money. But it's kind of locked down. A whole group of people, including myself, have jailbroken it and reverse engineered the executables to make it expandable. So as I stick these things onto it, there probably are some options to integrate it into the onboard ARM computer. It'd be relatively simple to string in another USB hub and just add some code into there. But that would just be for raw control, right? Just to control the serial bus servos. For whole body reinforcement learning motion controllers, there's not enough oomph in it. Unless one of us figures out how they did AI mode for the dog module, or how to enable the NPU to give you about 9 tops or 6 tops of AI compute. So to do anything super fun, you need to have the brain somewhere else. And so just as a placeholder, I put an Orin NX 16 gigabyte, just sitting on top so I could kind of get used to it. They're about $800 or $900. So again, not cheap. And then if you want to go like full brains on board, there's an Orin AGX system for about $2,000. And so then the game plan would be to connect everything up to the Orin with a buck down converter off of the 32 volt supply line off the back, and then just plugging it straight into Ethernet. Because for high level stuff, there's a high level command structure that means walk over here, stand up, sit down. You can do that over Wi-Fi. There's a couple of different unofficial and official ways. But if you're running this full neural network model, you're running full body motion controllers at 500 updates a second, and that's not going to work over Wi-Fi. So that means you need to plug into Ethernet. And so even if we can't figure out, even if we can't figure out how to re-enable it in the hardware, because there are literal USB 4-pin USB ports exposed on the main board, like
there's other ways,
style,
right? Just
plug in an USB Ethernet adapter and work that way. So we've got options.
Yeah, so full disclosure, the newer dogs have the Ethernet port apparently disabled, like no signals come out at all. I can't figure out how to make it work. So that's a difference depending on when you got your dog.
Yeah, so we've done a byte comparison of the boot partition, the U-boot partition, the user partition, and from someone's dog that has it enabled to those that don't have it enabled, byte for byte, they're identical. The E0 shows up in Linux, like it
I see it.
So
I think it's unplugged. I think they cut a trace or something like that.
yeah, so anytime you want to spend an hour, we'll set up a Zoom with the camera. We'll open up the app together and we'll compare notes.
So yours has it.
Yeah.
So I've got an Ethernet port. It's sitting there, and I probed it. I see absolutely nothing on the Ethernet port.
They did it on purpose. They're like, wait, people are.
I think so, but I see E0 in Linux. So like it thinks it has it, but there's nothing coming out of it. So I think there's
It's not like damage.
I'm not the only one.
Somewhere around March or April, we started getting reports of it, and I'm like, why? Like the audience that's doing this is not the audience that would spend 50
Yeah.
grand
No.
on it. So
Very.
yeah, and I keep meaning to ask because the Legion guy took the ball and ran with it. I keep meaning to ask him, hey, I know the mechanics of this jailbreak, but not the details. I'm like, hey, what do you think the chances are that the G1 will be set up similarly? Because it's got the same name for it. On it. They so yeah, and again, a list of things that I'm keeping an eye on, but won't do. Yeah. So yeah, so I'll update you guys during the next month. And until then, we're trying to cut it off at 44 minutes or 45 minutes.
Good job.
So yeah,
Yeah,
that was questions. All right, thanks everyone.
Thank you. Yeah. I'm good with that. This was fun. At one point. Yeah, this is taking,
Maybe I should try.
yeah, they usually go up to like 40,000. Those robots, it's crazy.
Sparkles, that's a good thing. Did you see what it walked on when you came in? Yeah, well, during break we'll
Try to pick it up if you want. It's a thing.
Something to load. Network.
There was 4 of those in the robot. There was a bottom plate.
Actually, this is a lot lighter than I thought.
Yeah. Yeah, it's also pocketed pretty heavily though. And the other side has a bunch of pocketing as well. So it is weight safe.
Got it good, right?
Yeah, they like sport a big full body.
But the dialogue, the web page doesn't let the front.
Oh, you know, yeah, Beachnets.
Oh, yeah.
Yes. Yeah, that's the blade of the other robot just coming straight at it. It feels like, it looks like a piece of gum and someone like ripped the piece out.
Yes.
Yeah, the tone of the robot is usually aircraft. Something changed to be
I've actually like 6 times.
And it just worked every month except for
Last month. It's like it's down.
something happened.
Yeah, basically, I start from scratch.
It is indeed.
I have time.
Yeah, I think all these fast rounds. See if we get it moving.
You ordered one during the meeting last month, right? Did it cost around $2,000?
Right, no problem. Just have to think.
now I prefer rubbers.
The car drives somebody and then like 2 days later it showed up. Very, very bad.
Where's the Shenzhen province, standard,
I don't remember.
Silicon Valley in China.
This guy named Peter helped me out.
Oh, wow, Peter, that's his thing. Yeah, they, the Koreans do that. I don't work in a lab like for like $10,000 or $50,000 robot, but yeah. So I've never done.
Servo.
Oh, yeah.
Oh, wait.
We've, I got to see it outside, you know, after the meeting, last month, was it? Or, yeah. Or you were here. Driving it. Yeah, you were driving. Yeah. So it finds up.
I want to choose. It almost ran into the furniture. Oh my gosh. Oh, so I got really, I said it figures out that stuff. Like perfect. Maybe there's a very I found out I should. One of the so what I ended up having to do is turn it back on again. I'll go over the like where the like yeah. It would be something. I guess it would be. There's a lot of and it's like no. Inside, everything like looking at it. Then everything on fire. So there's two horizontal bars that go to sweat zeros. And that's what the legacy amount is. That's what they say. That's mine. It is not sorry, right? Yeah. Yes. Right now it's working indoors and working on the outdoor. Wait a second. I fixing that program fixing on that. No, okay. No, mine it goes very slow. It's a crawler. Doesn't go very fast. I did a lot. What it is to start. Yeah. I just, you know, the bigger angles in the pad gets caught in itself, and it's like there's friction. You know, and just
that out. Just throttle based on the turning, amount of turning. But yeah, there's other than that, and then there's well, this lecture's about the problem I had with grounding and. If you're hacking a device, you don't have the schematic. For it. No, but yeah, we don't know there. Yeah, I don't, it's funny. I don't run fast, but quality. But I mean, yeah, but I think yeah. I mean, you can figure it out. Curves and stuff. So I sort of estimate, but currently, yeah, it's still a work in progress.
Pull the head off. Magnet. I think. So. Doesn't matter when yeah, I've also this translate like this one. We get more movement this way. Yeah, so the robot we get the most, and then my routers.
Yeah, thanks for saving. Thanks for letting me use that. Otherwise, I don't have an unlimited plan on my phone. Otherwise, LTE. Yeah,
there's a like which are the four.
Are you gonna get one too? Yeah, I have another project, but the quality is pretty amazing. I mean, if you're quality. I get this. I'm gonna start my talk. Thank you.
All right, let's continue that, right?
All right, I'm gonna start my talk. No audio.
All right, thanks, Jim. Sorry.
Share sound optimize.
Can't play we can't play commercial music.
You'll be stricken from YouTube, right?
Yeah, it's a lot harder to edit it.
Oh, this is just I can't even play a few notes.
No.
I'll have to mute it. I'm sorry.
Mute it for
Yeah.
okay, I'll do it. Dun 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 dun. Dragnet. That's my best interpretation.
So good, you might get stricken for that.
but that's a personal performance from a 50. So my talk today is about my issues or about a crime scene where a Truckosaurus lurched when I'm controlling the steering and everything is energized. Suddenly the motor jumps and I'm only controlling the steering. So why why is it doing that? So I have a Truckosaurus is my project where I'm turned a RC car into a autonomous vehicle by hacking in to the electronic speed control and adding a teensy microcontroller and a Raspberry Pi, just to give you the background. And a teensy controller is I installed to take over the signals to the steering servo and the motor. And I added a manual mode that lets you original remote control, and the signals are received by the RF receiver and forwarded to the teensy, which then forwards them to the control, to the actual steering and motor controller. And so in this manual mode, when I'm adjusting the steering, I get this sporadic full throttle for fractions of a second. And luckily it's up on a block, so it's not like going off somewhere. And so this talks about my debugging of this problem, and that kept coming back. So the main suspects: grounding issue, signal crosstalk, or software error. Because like, why would the steering affect the throttle? Doesn't make sense. They're different signals. So I can't show you the exact original behavior because I didn't. I should have filmed it. Like I say here, note to self: document crime scene before altering anything. So the following, I am able to reproduce something similar by essentially pulling the grounds out or making it so that they're not the tied grounds, and we'll get to that in a minute. So here's the video. Yeah.
A lot more violent than I expected.
Now this is a simulation. It wasn't quite that bad. In the real thing, it was a bit more intermittent, and it was only when I was steering. But that's kind of what would happen in a more, just an obvious way of really enhanced.
Yeah, I had the same thing. Yeah, and also the steering would go wah, wah, at the same time that chaos was happening.
Oh, well, in my case, I turned the steering, and that's only when that happened. Like, I could throttle and it would be smooth, and then the steering. Okay, well, that's very interesting. You had the same problem,
Similar problem.
or similar, maybe. So in this simulation that I just showed you, the grounds are not tied. So one of the fundamental kind of rules of developing a system like this, where you have two separate circuits. You have a teensy microcontroller. It has its own ground, its own battery. Okay, the ESC, the truck itself has its own battery. There's two batteries. You need to connect the grounds together for these circuits to work properly together, so that they have a common ground, and then the voltages will be predictable. So this is an obvious, I've made it happen here by pulling the one ground, not connecting both grounds. That's what happened in this video. In the actual real situation, I had a line connecting the grounds, but there was some problem where it was intermittently failing. And it was only when adjusting steering, but how could steering affect on the steering affect the drive motor PWM, and it's on another wire. So I use DuPont wires. Are they shifty?
Shifty.
Well, that's in all the 50s. What's that?
All your old gumshoe.
Yeah.
Oh, is it?
Yeah, we got kids in the audience, Jim.
Yes, I know. I noticed that. That's part of the crime theme here. Shifting characters. So I crimp my own too now. So I've crimped a few DuPont wires, or at least one that didn't make a good cable. So I test all of them with a voltmeter, with the connect disconnect mode on the voltmeter. So it just beeps if it's a connected from both ends basically. But maybe this wire I had some kind of more subtle fault, like a resistance or something. But it's hard to. I didn't keep it. I kind of I decided, okay, I got to go in there and just clean it out and start and rewire some stuff. But initially, I would go in and I would open it up and then like fiddle around, and the problem would go away for a while. So
An intermittent problem.
yeah, intermittent, where it wasn't all the time, but it seemed related to some kind of loose connection, because I'd open up the wires and no, these were DuPont, like I said, so now so here's the proper throttle PWM at a rest state, 1500 microseconds, and that's what it looks like. And that's when things are working well, that's what you get. But this
here it is connected to just the truck's ground and the signal from the teensy, which looks wonky.
So this is I reproduced this for this talk here by not connecting the teensy ground, but so it's all the signals coming from the teensy, but the only ground at play is the truck ground, the escape, the ESC RF receiver. It has its own ground, and you see that this signal is. See my mouse here. This signal is definitely messed up. It's supposed to look like that.
Here it is.
Ground. I connected to the truck's ground. Yeah. Now, and you'll see another one where I'm simulating a loose connection here. So, trying to solve this problem, I would open. I was in a rush most of the time here trying to do other stuff. So I'm like working on other things. So I would open up the wiring box, put the wires in, and then probably go away for a while, but it would come back. And I had a feeling it was grounding, but I didn't scope it at that time. And for this talk, I tried reverting all the fixes I did, except I didn't have the original wire. But I couldn't get the problem to happen unless I just pulled the second ground out completely. In other words, just use one ground. But that's not how. When it was really happening, I thought it was connected, and there was a wire going from the teensy ground to the escape ground, and the grounds were connected. And I checked that, and it was in, and so.
And here's a simulated loose ground.
Yeah, so this is kind of what happens if you if you
and
kind
if
of have
both
the ground
grounds
coming
are
and going.
tied securely,
I see.
then
But
you
yeah,
get this
this, to show you what might have been happening in the
nice
when I had the problem, because if multiple, right? In other words, so it probably, the width. I don't, not exactly how it would have interpreted it, but as you make this thing wider, the truck goes faster. So, I don't know how it would have interpreted this negative one. If we don't know if this is the signal, but that actually was happening. But this is, from that spasm you just saw, this is, I didn't scope it while it was spasming, but this is essentially a measurement of the same situation. I just turned off I disconnected the motor itself so I wouldn't have a spasming robot while scoping at the same time. So here's the wiring beforehand, before I made any changes. And, I was thinking perhaps the fact that these signals, or both the PWM of the steering and the the steering and the drive motor were kind of right next to each other here, coming from the teensy. So I'm like, well, is there crosstalk, or what? And then I'm like, okay, I have another ground here I could use. So I figured, to make sure things are grounded well, maybe I'll just double the ground, have two different places where I take the teensy ground and connect it to the receiver ground. That's over here. This is the receiver. Can we make this bigger? Your servos, get their power from your receiver. Yeah, so right. The receiver breakout has like the it has 3.3 volt for the signals, but and then the servos are all connected to the receiver. This is the receiver, this little block over here. There's the power from your ESC. Power comes from here, and that's like up to 6 volts or something for powering. But the signals are 3.3 volts. So rewiring. So I got in there and I decided 2 things, or actually there's 4. I have to update that. Replace the ground from the teensy to the receiver ground rail. So I just figured I'm pulling that wire out. I don't care if I think it is good. It's something weird going on, so I'm just going to replace it. And then add a second ground from the teensy to the drive servo connection directly. So before I was just adding all these left rail, I call it the rail, the left column here should all be ground and all connected. But I was connecting the ground to from the teensy through one of these, but not the one going directly to the drive motor, which that's this right here, the drive. So I figured, all right, I'm gonna shortcut it so that I make sure the second ground goes right to the drive servo connection, just in case there's some other weird thing going on. But there's some sketchy problems you might have from that second one. You start making ground. And I don't know what, I'm not really, I don't understand ground loops too well. You're making an inductor basically. If you have a ground loop, you're creating an inductor. So when you have like your motor, it's energizing its coils, so it's like a transformer, and the magnetic flux will drive voltage in that ground loop. You got it back. You mean back EMF? Is that what it's? It's like that. Right. Oh, so you're saying it can catch up. If you have a loop in your ground, it can catch magnetic fields and turn them into voltages. And you have a lot of magnetic fields from your motors. Right. Well, this worked, doing this worked, although I just took it out and it also still works. So
Yeah, I'm not saying it's gonna cause, I'm just saying it's sketchy. It can, you have to be careful, like what is the physical.
So you're talking about, so what I'm doing by, here, I'll show you, well, I'll show you the diagram.
Bring up
So-
a whiteboard bring up a whiteboard and do a quick doodle. If,
Oh, well, I
oh, you got one? Okay.
I mean, I have a thing, let me get, so I'm moving the steering PWM and signal output pin away from the motor signal output. So I wanted to space them a little bit more. And then move the remote throttle PWM a little bit away from the remote steering PWM input. So basically, I'm just saying I'm spreading out these a little bit so there's some space. And you can see here there's more space now. That I added like a space, like there's an empty pin here, and then there's a couple empty pins here, in case there was crosstalk or like even a wire hair or something. But yeah, I added this ground. I added this ground directly there, and then the other ground is here. So there's two grounds. So you call that a ground loop. In other words, if I go from this ground, I can get to this other ground through here. That's a ground loop. So as I'm being told here live, ground loops are bad, or it could be bad.
Yeah, it's based on the geometry and all that.
It's kind of complicated to figure out whether, but
You're something.
The pins are traced on board.
yeah. Yeah, I think so. Oh, you mean on this board? I would only assume so because they're both listed as grounds on the, and these should all be connected. But I didn't, right. And so this was just, my throwing some effort out there to cover multiple bases. But it turns out if I yesterday or whatever the day before, if I take out this new ground, it doesn't break anymore. I can't make it malfunction. With the single ground's good enough. So I may end up just pulling that one for good to avoid ground looping. So here's what it's supposed to look like.
So here's an example of everything working properly. I can move the steering alone, no jumps. You can move forward,
This is where it would jump.
steer at any angle, can reverse. Everything seems good with proper grounding.
Is the case closed or not?
It's wondering if once it's in the ground and it's getting jostled around. If you can
Yeah, and
get-
the thing is when I would drive forward, it's shaking even more than when you do the steering, but the steering set off the problem, but the drive didn't when so shaking, it wasn't 100% shaking either. It's like not 100% anything.
If you look at the way your an automobile is starting on because compared with the other draws the maximum top. And so might consider using servos much bigger than the signals and connected as directly as you can. Because look at the way wiring, I had trouble figuring out where the red wires from the 3 servos are they all connected together? But maybe they are somewhere in this.
You're talking about, I have a printed version here you can hand out actually.
That looks like but what
Yeah, the power's coming from here, This is the receiver block. And I'm not showing the battery or anything, but power comes from the middle column here, and the ground is here. And this is coming from the main battery of the car.
Okay, so the receiver is.
The ESC,
Yes,
the thing on the bottom,
that's this.
it has a VEC in it. To
Yeah,
provide the 6 volts for the servos. And
Right,
so
VEC.
so you run that up. It turns out you run it up to the receiver, who has a passive block of headers there that distribute that power and ground to your components.
Right, so that the power is coming from the main battery is a LiPo 11 point something volt, 2S, whatever, and so there's a VEC which brings down the voltage to 6 for this purpose, up to 2 amp or 3 amp, I think is a. So it's what is VEC? It's a
Battery elimination.
battery elimination circuit. So that essentially you can get a 6 volt for your lower voltage electronics out of this big battery, which also is powering the main motor. So that's there's two batteries. One battery, the main battery powers the motor, and then that battery has this battery elimination circuit. So then it dual purposes as voltage for the electronics, the receiver, and the servos, right? And then there's a second battery that I installed, powering the Raspberry Pi, and the Teensy. That's coming from a second 5 volt battery. So then the servos come from this the 6 volt escape from the main battery.
Okay.
It's a 6 volt regulator, essentially, yes, battery elimination circuit. And so, and then the Teensy is being powered by my own battery. But so there's those 2 circuits, and the grounds are tied. And okay, well, I was in here. So my conclusion is maybe expected DuPont ground wire was at fault. Why was it triggered by steering and not throttle? Maybe crosstalk. I don't know. I rewired just a little bit, really. And it turns out now when I undo those, I undid the movement. I undid basically yesterday, the day before, I undid the separation, and I undid the ground, the second ground, and the problem doesn't happen anymore. And then I undid one other thing, and I undid a software change I did, and that didn't bring it back either. The software change I think it was just a startup thing, but I was not initializing my initial PWM value to 0, and then I wasn't clamping to between 1,500 or 1,000 and 2,000, but that seemed like just an initial. When the thing starts up, it would do something movement, and then it would be initialized. So that code change didn't cause this middle of the run problem. So that's basically the the mystery of this rounding problem. And it sounds like Brian had something similar during your build, which is kind of curious. Like what could that be that it would cause both of us to have this problem? But it obviously you're working on a circuit that you don't have the diagram for completely. This is a commercial toy, whatever, or RC car, and you kind of are figuring it out from other people, and hopefully it's a fairly simple system, right? It's just that voltage regulator and an H, basically ESC, which is kind of an H bridge to control motor controller, and then some servos. And the only complicated part here is you're bringing in a new circuit with a microcontroller, and you better make those grounds tied securely. So I also, one other thing I didn't mention, I put a slightly thicker wire on the ground. I believe I can't remember now if I kept it that way, but I was worried maybe the ground, wire, the initial DuPont was too thin or something, sketchy. But anybody can take a look later. Yeah, and see, I don't even think it's, yeah, it might be a little.
Your ground wire shouldn't carry any current.
No. But
They're kind of like two disjointed circuits, right? And they're like tied together with the ground.
yeah, you mean
You have a ground connecting your control tower to your car power, right? You're connecting those two with the ground. And that's the only way they're connected.
they're connect. I mean, right, the ground coming from the ESC is essentially going to the receiver breakout, and then also the teensy ground was going to there as well. So they're, those are on the same rail, so they're connected. The two grounds are connected via the breakout. The receiver breakout is what it's called, right? That's that 9 thing or 12. That's what you mean, right?
Yeah, I'm saying that is because it has very, very little current. I don't need to take
Right. Yeah, it's secure. Well, the other day I was trying to make this problem happen again so I could try to scope the real problem. I put the second ground, like barely touching, and it still wouldn't happen. It was only if I actually, literally, like I went from plugging it in plugging it in halfway to 3/4 to 1/4 to just resting. So it was like this, and the problem still didn't happen. Then I just took it off, and then you saw that.
Yeah.
Basically, I had to literally just absolutely it had to be a foot away.
Sometimes they look like they're on and they're not grabbing the pin at all. I mean, they
Yeah, but I was very, I've been very careful with this. I put them in and I kind of really feel around. Can I
make sure it's holding.
I tested them now, or if I can hold slightly and it moves, then I'm not happy. Then I, get a different one or whatever until it's. But ultimately people said, Jim, you should solder all this. But I'm like, what if I want to change something later?
Yeah, for better or worse, the Unitree guys have been building mobile quadrupeds for like 4 years now. They'll secure the connectors with data silicon. It's not just strain only, it keeps things connected when it's jostled.
Yeah, I actually did try something. I have this stuff called it's like chewing gum, basically. It's this really good Loctite, I think it's called. Really, it's like the most versatile thing I have in my garage now.
Blue tack.
Yeah, it's lock.
Blue tack. It's
They call it Loctite too.
yeah, Loctite's the brand name, but
So
the common name is blue tack.
Tack is this gum. It's basically like the dry chewing gum.
Like silly putty.
Yeah, so silly putty. And so I use that and put it. I'm using that all over the place. It's used right here to mount this. The IMU. I moved my IMU. So I use that to, in lieu of using actual glue gun, I use that to secure, because it can form a fairly tight, it's tight clay.
Yeah.
And that didn't. I did that, and the problem was still happening. So obviously, in a DuPont, the real important part is underneath the actual, inside the metal where it's connected to the pin. If that has some play, then it doesn't matter how secure the thing is, the metal's up. The contact isn't working too well. But again, it's not, I can't make that. Generally, DuPonts have been fine. I've had very few issues. Until like when I started making my own, I checked and I made a bad cable. But then, I'm getting better at it. And then of course I throw that out if I do it. So I'm not sure what happened here because, if you unplug, you get this horrible thing. You can't use the robot at all. It goes into a complete fit. If you plug in just a tiny bit, it's working. So what did I have that was not working? It's just really hard to, like, maybe it was a resistance. I almost put a resistor on to see what would happen if I had a resistance to ground. But I'm like, all right,
The best kind of issues are intermittent issues. Right?
That's right.
Yeah, can you hear me? I'm not sure about the intermittent stuff. I've had exactly the same issue on a much bigger robot. It was a motor controller, a big battery, a voltage converter, an Arduino, and a Pi. And yeah, it was like we were trying to code all the code issues. Could have seen you probably did the same thing. It's like, oh, I got to change the code. I got to put a low pass filter on. You try all the stuff, and then eventually it turned out we were missing one ground wire, I think, from the Arduino to the speed controller. But the intermittent, it's hard to say if it's a loose connection. I mean, this you're talking about, electromagnetic noise, and Bill could probably talk for hours about this stuff. But it may be that the noise and interference varies. So it may be you're thinking, oh, you're pulling the wire in and out, but it may be that it's just that that particular command or whatever is causing the issue. It's very finicky, and we spent like half a day changing the code, and finally I said, oh wait, we're missing a ground wire, plugged it in, and it's like boom, it worked. So it's just crazy. And we thought we had it working, because we were making the code be more and more resilient to the noise, by adding filters. So
Anytime you have a motor in a circuit, you have a winding that looks like an inductor to the ground. So what you're doing when you're trying to pull all that current, you're making the ground move around because of the inductance. What you probably ought to try, and I sent you an text message on the chat, is taking out that motor ground and running it straight to the battery ground and see if that makes it go away. Around all the other electronics, just straight to the battery ground, because that's the most 0 point you have in the circuit.
oh,
So here's an example of everything working.
grounds are changing or floating or something.
Yes, it's the inductance. That's what inductance does to grounds. That used to be a problem with the original high-speed logic chips. That the wires in the packages would actually cause inductive bounce on the signals. And that's what you're seeing. You're seeing an inductive bounce screwing up your grounds, and you don't know what that's going to do to the thresholds on the input to the other logic gates when that ground starts moving around.
Interesting.
So it's not just common ground, it's where you attach your ground.
Yes, you need to try moving that ground from that motor straight to the battery ground.
You don't show the motor here. I think that is how you have it connected, right? The motor.
Well, okay, the
goes through the ESC.
The motor's ground goes to the to the H bridge.
Goes to the speed control.
The speed control. I'm not showing you the actual drive motor in this diagram, but because that's part of the original truck. But this ESC is essentially, it acts as a H bridge, right? I mean,
Yeah, it is.
So. You're seeing here the other side of the BEC. This is the other side of the regulator. On the hot side, the high voltage side is connected ground and power to the motor. So this is all just the regular, the logic circuit.
And I'm betting when you disconnect the motor, you see absolutely none of this.
Oh, you bet?
Oh, the drive motor?
Pull the drive motor, see what happens. I'm betting it all goes away.
Well, I mean, I can't repro it anymore anyway. If you, it's like the problem seems to be gone, unless it comes back. You know, the only way I could make it happen now is not tying the grounds. If I don't tie the ESC ground with my low voltage battery, which is over here, say, then the problem, you know, is really bad. But if I tie the grounds, it's gone. It's gone.
I hate to say this problem will be back.
Oh, so you're saying, right? I would have to go right to the main battery
And tie its ground to the motor ground right there.
or to the
Do a flying lead instead of a 3-pin DuPont. Connect the signal and the voltage to the ESC and tie the ground straight to the battery ground.
How can I do the? I don't even have to dig into the surface surgery.
Yeah, I don't think I just have issues with those little skinny wires and big motors. And
But this is on the other side of the. I mean, I'm talking about like the motor's not even on; it's off, and then I'm moving my steering, and the motor starts jumping, like it got a signal.
Yeah.
well, it could be inductance from the servo motor too.
Yeah.
But looking when you put that scope trace up where your ground shifted, that's an inductive problem somewhere.
This one.
Yeah.
And here's a simulated loop.
This one here was basically, you know, a fabrication of just not tying the two grounds together.
Yeah.
So I'm hoping the problem stays away, but if I'll look into it, you know, if it comes back, I'll investigate your advice.
And for the ground loop, and I'm as guilty of this as everybody else, is you tend to run the grounds wherever it's convenient, you know. In other words, you end up that's where you get the ground loop, and it's better to all the grounds should be a home run directly to one point, like on the battery and all that. So, you know, with the controllers, and I always use the controllers with like servo IO shields, so you end up with all the +5 ground and the signal on one thing, and that ends up creating ground loops. Now, in audio engineering, you know, if we had an audio engineer here, they deal with ground loops all the time. It creates hum and the microphone lines and all that, so they're just completely careful about that. But we tend to run grounds like kind of in circles and things, and that, like we were saying before, creates that issue with the signals and from the motors. So yeah.
Induction, right? Is what you're saying, right? And that
So
creates
home runs on all the grounds. Yeah. That's the-
Transformer.
Oh, it's a winding. I get it. I think I
Yeah.
got it. So I will take this one out. But I mean, as far as I know how this works is this ESC, the ground to it is coming from a BEC circuit, from a regulator, and the ground from that is from the battery, from the big battery. So
Put a meter on that and see if it's connected directly to the battery ground without powering anything on. See if you have 0 ohms between that point you were just on and your battery ground.
if that's the case, and it really is, yeah, I have to do some a little probing to verify if there's 0 ohms between them.
Yeah, and if there is, that's not the problem.
Hmm.
And you got other issues.
Yeah. So anyway, well, thank you for the input. That's good.
10-minute one.
Anything?
You might want to try out swapping that one steering servo. Do you have another one that same size?
No, well, I haven't. No, I don't. I don't know if I have one. This is the one that came with the truck, so I don't even know what exactly. I think it's as similar to a regular hobby servo size. I probably do have one, but I don't think it's as good as that one. The ones they put in here are pretty good, but
These trucks are completely solid. The electronics are until you start messing with them, everything works perfectly.
Yeah.
So
yeah, again, this is a commercial product. I'm just the only thing I've added is the teensy and
yeah,
you know, this extra circuit here, which you know you're messing around with the PWM, which of course you can cause a lot of, you know, you can make mistakes and cause the thing to be, you know, in bad shape. But I'm doing as much diligence as I can. But yeah, I'm kind of still not a, you know, I'm not a real expert in analog side of, you know, electronics and grounding and all that. So
I would say with all of your investigation, I'm like 99% convinced you just had a flaky ground connection between the two.
that wire.
And you thought it was crimped correctly, but it was, you know, there's
I thought I tested things.
That's what said flaky, right? So it could be flaky that you twisted the wire a little hard and it was a solid wire and that you got a little intermittent short.
I'm getting a little bit worried about DuPonts because I notice if you tilt them a little bit too much, like when I'm taking the top off, then the IMU doesn't boot up right or something. It's almost like I'm getting a little bit like wanting to figure out a better way to wire.
Yeah, a single DuPont is definitely going to come out in a mobile robot like that. You're bouncing all over the place. So I've either used terminal shields, and there's some cool kinds too that have like that sort of angled screws and all that. So you're screwing in the wires, or if you use all three, use an IO shield, and you have all three wires, it's a lot stronger. I mean, it's not, you know, as strong, but it's way better than a single DuPont just coming off the pins of the processor itself. So
You mean a three connector DuPont?
yeah, the IO or servo shields, they have three pins on every IO pin, and basically they have ground +3 or +5, and then the IO. And the three of those together on a single, you know, like a servo style connector is way stronger. It's less likely to pop out.
The way you do this is each pin on a DuPont connector has so many ounces of friction between the pin and the post. So as you add more pins, the amount of friction goes up. That's why it works that way.
So don't use single pin housing.
Don't use single pins ever.
2, 3, 4, I think 5 came with my kit. I have up to,
Yeah.
But unfortunately, you know, some of the pins are further apart, so I mean, unless I go back to, actually, it looks like I tried to solve the problem with something that's not really helping by moving the pins, separating them or something. So I can go back to, I can use multi-pin housing. Is that what you call it?
Yeah.
From my DuPonts. You still call that a DuPont, right? It's a
Yeah, they're not, but you call them DuPonts.
It's like a three-pin DuPont housing.
Yeah, that's a standard hobby servo connector.
Yeah, same thing. Yeah, you're calling. Yeah, go ahead, Brian.
It's
I don't know if this helps too much, but I put cable ties on groups of wires too. So
yeah,
it tends to keep them from like moving independently, and I think it has a little bit less, you know, free play and less chance to come off.
Yeah, I do something like that, trying to, you know, wrap them in like little ties.
So that should help a little bit.
Yeah, but again, this was the whole work in progress, so I haven't converted to like but now I have pretty much have the final cabling.
But you know,
might as well convert. What did you? Yeah.
If you scope it, so we're talking about like if you still have issues, and we're talking about that. If you can scope it, if you can move your steering, if you can move your throttle, and you still see clean signals, I'd probably say you're.
Oh, I just scope it while I was doing that.
Yeah,
good test.
And to see if it's still clean, you're probably okay regardless of the noise.
Here's one to keep you awake at nights. I found one of these and I spent weeks trying to chase a bad signal down. Turned out the trace on the circuit board was cracked. It was intermittent. It was not in the cable. It was not in the connector. It was on the circuit board the connector was mounted in. So all kinds of stuff can go wrong. You gotta.
Now
Murphy rules the universe and we're just all his servants.
Did you solder your own teensy headers? Right? Are they cracked? Are they solid? You know?
I didn't solder any.
Okay. I
Or
didn't
wait,
try that.
oh,
I'm
you
sure
mean
they're mounted pretty well.
I'm a meticulous solderer though. I like use a
Okay.
magnifying glass afterwards and
Okay, so
any
Good.
and it has to look perfect.
All right,
I won't pass it.
good to solder our stuff for us.
Yeah. I like it's the OCD thing, you know, it's one of those satisfying things to like, oh, there's a solder joint that's not perfect. Remelt it. Yeah, I guess that, yeah, I mean, I don't know if they want to do it, but, what was it, who was talking about the breakout or the hat? You're talking about the hat?
Carl put a link.
Carl put a link?
Yeah, so are you using a Pi Pico? I wasn't quite sure, just looking at it quickly, but you can get these for all the different boards. So I put ones up for the Pi Pico. I thought that's what you had, but you know, whatever board you have. But yeah, you either have the IO/servo type shields where it's 3 pins together, so it's less likely to pull out, a lot more friction, and you don't need to connect the ground wire, right? As long as the ground is coming from somewhere else legitimate, you can just keep the pin, you know, but cut the wire. Well, otherwise, the terminal shields, obviously, you're screwing that down, and the second one I posted is there's for every kind of board, there's one of these that have the sideways from the top terminals, and the huge advantage there is you're not trying to shove a wire in the side, you know, in which is always inevitably a crowded situation. I mean, I use the sideways ones a lot when I have controller and wires can go every direction, but in a tight situation, the ones that come from above, like those kind, they're a lot easier to get to because you just come in from the top. So but there's there's tons of ones that have the side terminals.
Side and okay, yeah. So right, yeah. The best way is to kind of use better connections than some sort of like desktop hobby, you know, test. You know, you gotta have terminals and things like that.
Yeah. And those two, the lessons are learned from the robots in my picture behind me here. So out in the field, so we had the same thing. DuPont's just popping off individual ones, and it was terrible. But the 3-pin connectors hung on pretty well. So
Yeah,
don't use those anymore. There's no more DuPonts in that thing.
All right, great. Yeah, like, is this what you're talking about or not? Just like this, really, right?
Yeah, I just call those 0.1 headers. I don't know.
Yeah, use the standard server wires. You cut them, and then you got all the wires coming out. Yeah, I mean that's the one nice thing about it is there's a million servo connectors you can get. So
Build my own with this thing, these housings.
yeah, well, bless you on crimping a DuPont because I hate that most of all.
With a passion.
I buy them. I buy them pigtailed, and you know that's.
Well, I would buy them. I like, hey, I want it my own length, so it's not too long and not too short. That's why I started doing it. But then I realized, oh, you can make a bad cable, and you can have, you know, easily or have little piece of metal sticking out, or I don't know. There's a lot of pathological cases, but
It's nice
practice. You get practice.
Yeah, you
Like,
got
I
at
just
it or
started
good at it. I started out really, really bad at
How
it.
about the connector tool, the crimp tool? Like if you're trying to wing it with a little pair of pliers, no.
No, yeah, the
You need
crimp
actual-
tool I have, and yeah, I bought that kit, and
Yeah.
it's satisfying when you start getting it right. It's like practice, like anything. Anything like soldering or any of these skills. It's a very muscular, mechanical thing that you have to do and get it just right in, and you know, have this procedure that you can repeat over and over and over, and that, you know, when you strip the wire, it's exactly, you know, a 1/8 of an inch, you know, and that sort of thing. And,
Yeah. Although I have to admit, at my age, now I have to do it with a magnifying light. So I can see it.
oh, really? Luckily, I'm still nearsighted, so
Lucky.
You're lucky.
maybe I'm lucky. I never had the surgery, so I'm like, I kept my nearsighting.
Yeah, just 2 years ago. And now.
There's a reason aerospace companies don't let engineers solder. There's a reason technicians get paid a bunch of money for doing that kind of stuff.
Technician. So
And this is the kind of stuff Carl's talking about. I've got a whole drawer full. And the trick to these is you want to decide what spacing you're using, because the metric ones look just like there's not much difference between 5 millimeters and 5.08 millimeters till you start stacking them up. You want to be really careful because they come in both metric and English unit sizes.
Oh, the fin spacing, we're using
Yeah,
0.1 inch, which is.
Yeah. 0.1 millimeter.
Points of the spacing, yeah.
Yeah, the spacing you want to make sure you're doing in inches or in metric. Inches, if you're soldering them into some kind of a proto board, you want the inch ones.
Oh, right, the proto boards are all in
Yeah, are all in 10th inch. So you want the
like that.
Return, of course, you guys, they keep eating. Right now, we're gonna do announcements. The main announcement is the Makerfaire that's coming up on September 14 and 15. We were debating whether we were gonna go, depending on how many people wanted to go. If we have enough for a booth, then we'll go. If not, then we're gonna have to skip it. The good thing is that the good folks at the Makerfaire, they offer to just transfer our old application over to this year, so we don't have to actually fill out the entire thing. We would just need to update, whatever we were gonna do this year. Can I see a show of hands of who wants to attend? I guess I can. At the Orange County Makerfaire. Yeah, so it's in the Orange County Fairgrounds. The 14th is our monthly meeting though. Oh. So, but it is the 14th and 15th. Possibly we can do the 15th. So, anybody wants to go? Online? No?
I'm good either way.
Okay, so Carl is
I'm available. Yeah.
There was someone asking about the guy who runs the combat robotics. He said that he had a bunch of Hebicon stuff. I don't know if you guys know what that is. Like intentionally crappy robots. It's sumo, so there's like a white platform and you have to push them off the platform.
Yeah.
But you build it out of like stuff you can find day of. So the idea was maybe people could build them like at the beginning of the day and then at the end of the day, like compete in sumo. And then some of the judging is like, some of the scoring is judging based, so if they try too hard, they get points taken off and stuff like that. You really want like bad robots. Like that's the point, is to just super low barrier to entry, just get people trying it. So someone has all the stuff to run it, but he is running, I think, 3 different weight classes of combat. So he didn't want to also run the Hebicon, but he said if anyone was willing to run that he could give off the stuff. So that's an idea, I think.
I mean, I'm pretty sure there's a deadline of when we can submit our application.
Yeah, so we need to give the venue a floor map by, I think, Tuesday. But
Tuesday?
Yeah, but then within the floor map, we can edit whatever we want. So like, we just need to tell them, like, this is a walkway and this is a walkway, and this 20 foot by 20 foot is exhibits, and that 20 foot by 20 foot can be turned into like 4 10 by 10s, and they don't care.
Okay.
For the fire marshals.
I mean, we can post it again on our website, because right now it seems like we don't have enough people. Right? No, anybody
Okay, where is, yeah.
think otherwise?
Right.
Yeah, it's tough. I was more excited about doing it this year, but with the conflict with the meeting, I need to be here first,
Yeah.
so.
Yeah, it's
That's true.
kind of a difficult scheduling issue. That's,
Yeah.
plus some of us have either plans, summer plans.
Okay, I mean, let's post it. Yeah. So, I mean, we might be able to do the 15th, which is the Sunday after the meeting. But I don't see too much enthusiasm on who wants to go. So we might have to skip it this year. Everybody okay with that? Okay.
Yeah, we'll make a post and see if there's any additional interest with the other club members.
Okay.
I don't even see where they, yeah.
So the next announcement is a bigger room. So lately we've been maxing out this room. So we started looking around what other rooms we could use, and we found an excellent candidate that has a lot of more seating. It has a built-in PA system. It has dual cameras so that one faces the audience, and at the same time another camera facing the speaker. Right outside is a beautiful open area where we can do all kinds of demonstrations. And next to it is a nice lawn where we can do our Rural Magellan stuff. So Alan is walking us through right now.
Yeah. So, okay. So, right now we are meeting, in, why am I losing it? Right here. So here's our parking lot. Here's our parking across the street. And after about 6 months, people were able to read the beginning of the forum posts or, and realize that we moved here. So awesome. But in case you, we're all robotics enthusiasts. I never said we were all technical. And when we first started meeting in person again, it was our core group only. Like there were a couple of months where I was wondering if there was going to continue to be a club because people's habits had changed and we just weren't coming back to our pre-pandemic levels. Well, that's changed over the past 4 to 6 months. Even in the room configuration here, where we can see 18 to 21, I would say comfortably, this is the limit of comfortably. And we're within 2 or 3 seats in the past couple of months of capacity. So we started looking for the locations to continue to grow into, because let's face it, robots are awesome and they're only getting better. So to show you where it is, based on the landmarks that you're already familiar with, and if you walk around the corner and walk over this way, and then either walk along this side or this side. So here's the outpost where we used to grab stamps, and we will starting next month. They'll be available. There's this courtyard right here. Here we go. We'll look at it the other way. And this courtyard has 4 hybrid instruction rooms. They're all identical. We're proposing that we move into this one that has tables and chairs for 50 people. It's set up for hybrid instruction. So there's a projector, there's a speaker camera and an audience camera and full AV setup. So it is a few minutes further walk inland, so to speak. I am almost 100% certain we can set up a QR code with walking directions that I can post at the door here for any stragglers. But yeah, it's a very comfortable space. It sounds like it's a great idea. So unless there's any objections, we'll start the process of reserving that. And then we should have it available starting next month. And it's closer to the outpost. So whether you're coming at it from this side of the parking lot,
This is a straight shot.
or coming around the, there's a walkway here. Oh, there it is. Yeah, a walkway here, back around this way, back through our old ET stopping grounds, which was right over here.
Oh, yeah.
To where we're at right now. Yeah, it's only a few minutes further inland, so to speak. That's our convenience store. They're open on weekends during the semester for quick grab and go if you don't want to head all the way down. Yeah, starting next month, they'll be opening again. They just close in between semesters.
So starting next month, I anticipate a lot more people coming into the meetings. One, because the semester's starting. I will be teaching this semester, and I will most likely give a 1 point extra credit.
Finally, that's the first thing they ask.
You will go in credit to this.
I mean, they're interested in robotics. The only thing is they're kids, college kids, and if they don't get any kind of credit, they don't give up. So if I give them 1 point extra credit per meeting, we might see a lot more people coming into the meeting.
That's good. Finally able to do it. You had to become a teacher yourself.
I'll do it myself.
I love it.
And of course, I'll reach out to other professors and the engineering department to keep London funneling in people.
As part of the thing, you can provide like a listing of previous stuff, so you get a feel for, and the YouTube channel and all that stuff, so they can get a feel of what actually happens in here. All right.
So what do you guys say? Next month, want to
Yeah,
thank you, everyone?
I say thank you.
All right.
absolutely.
All right, let's do it.
Yep. Starting Monday.
What was the over under and how do people get lost?
I know.
Have some stragglers.
Yeah, I'm hoping the QR code thing and then having a link in the directions. There's got to be some way to embed walking directions. I'll have to see. We'll figure something out on that.
Just the picture on the map and just the dotted line is probably good. They'll take a picture of it probably.
All right, good. Any other announcements?
Kidding.
If not, then let's just go straight into show and tell. Anybody online? Jim, are you ready?
Yeah.
The show and tell.
Okay, I'll add you to the list.
Yeah, add me to the list. I'm not ready right now.
Okay, so far you're the last one.
Last sounds good to me.
All right.
All right, so actually, let me just do this first part in video. So I've been working on Truckosaurus kind of navigation aspects for a while, and the hardest part to start with really is getting the sensors working and configured and calibrated. And I'm talking about IMU. This is an IMU 9250 in this call it a calibration cube that you can actually download on Thingiverse. Luckily, otherwise I would have made one. But so the IMU and the GPS are both need to be sensitive to error and standard deviation or whatever covariance you call it. And this is a 9 degree of freedom at 9250 IMU. It has the accelerometer, the gyroscope, and the compass all have to be calibrated. And this kind of hit me a bit, trying to rush through and using the existing code that did offer some calibration. But what I found out, and thanks to Ross, who's Ross Lunan there, is that people really use this external method, six position method to calibrate at least the accelerometer and the gyroscope. And so you have this cube, you connect your wires to an Arduino, and then you essentially use gravity as a known constant. So gravity is always going to be acting on this at 9.8 meters per second squared. And you can rotate it through its different axes, X, Y, and Z axes. to position it so that gravity is pulling down on that axis. So, and then you can do both the negative and the positive. So when you flip it upside down, you get negative G, or right set up, it's positive G. And then, so you do all these positions while the software is taking measurements, and then it averages those. And then you get, ultimately, I won't go into more detail, but you get the software, you run a script in Python, and you get back a scale and bias numbers. And those numbers then can be hard coded into your driver, because those numbers won't change appreciably anyway, because it's sort of you're calibrating the accelerometer and the gyro, and those aren't prone to magnetic interference really, as far as I know. The compass, however, is. So the compass, you have to calibrate while it's mounted in the vehicle or in the robot. And but I wanted to show you this cube, and I might come back and do a lecture on all the process of calibration. So I have that, and I have one other thing related to, yeah, I can pass that around.
Hey, Jim.
Any
Jim,
questions?
it's Ross here. It's Russ. Can you hear me?
Hey, Ross.
The conclusion of our discussion we had, and by the way, thanks for the thanks for the plug on the cube. That was a really fascinating thing you did. You know what I ended up doing? I ended up buying a new Oak D light that is equipped with the IMU, and it just arrived this afternoon, and it works. And it seems to calibrate when it turns on, because there's some small covariance, I guess they are, on the X and the Y, but the vertical acceleration, the Z acceleration, wiggles around 9.8, 9.75, that kind of thing, which of course is what it's supposed to, right?
Right. I mean, well, I forgot to mention one important aspect, and that's the mistake I had made initially was I used the software in the driver for the 950 I had a accelerometer calibration routine. Okay, so that runs at startup optionally. Unfortunately, when this calibration routine assumes that the accelerometer is perfectly level with the ground, and it takes measurements and assuming it's going to get exactly 9.8 Gs. My robot is never level. The mounted IMU will never ever be exactly level. It's on shock absorbers. It's all over the place. Forget about it. So it has to be done offline. Also, in my case, my Oak D light is on 2 servos that move, so it's not going to be a useful IMU inside there. It's a moving camera. So anyway, but yeah, that's cool. That if you should check though to make sure that whatever they do, I mean, you can't defeat physics. If you turn the Oak D camera like at 45 degrees and expect it to measure gravity, it's going to measure it across multiple axes, and there's no way physically you can calibrate that way. As far as I know from my studies so far, it's not possible. You have to, gravity is a constant, but it's straight into the earth. If you tilt, you're mixing the vector of gravity among multiple axes, and there's no way to tell unless you have a gyroscope that can, starting from startup, can keep track of the orientation exactly. Then you have to pit these different sensors against each other, or use them together or something.
Yeah, +1 for prototype orange for your color of PLA.
I'm still using that. That was a PPE sale during COVID,
nice.
from the Prusa, I think. I'm almost done with that reel. So the other thing I wanted to show you is, or any other Yeah, so that, if people are interested, I will study more and give a talk on the IMU calibration at some point, maybe not next month or whatever, but whenever.
Yes, definitely.
Because it could be a few months from now, but and then I'll maybe even have better idea. But the current problem, this is now I'm asking for help from people and have been, is my GPS, using the GPS sensor, I'm trying to locate the robot, have it localize itself to a real Earth, global position, right? And so, watch this video. I finally, let me hold on a second. Share. I finally got to the point where, hold on, where is it? So I can't find. Okay, share. Here we go. Yeah. So I got to the point where I started to realize I can use the RViz to visualize things, and myself without using some pre-done RViz file. So what you're seeing here is a plot of GPS or in real time. What happens once every, in this thing, I think it was once every second, or 10 times a second I'm having it go. So and then you'll see this other moving axis here, and I'll rewind so you can see. This axis here is sort of the map to odometry conversion, and that should not be moving. The robot is still, okay, right now. These numbers coming out here are the GPS location. And our GPS location is going to vary, as most people probably know here. You're going to get, several meters, plus or minus several meters. And this is indoor, so who knows how good it is. But each of these squares is a meter, supposedly. And so you'll see it wander around, but it doesn't go off into the distance. It kind of meanders, which is expected. But what you notice is this axis here, which is sort of my global position of where it thinks the map is relative to the robot, like the map center of the map, hard code, coded to the world, and versus where the robot is. You see it's like darting off into the distance here. This is the problem I'm having. Whereas these numbers are not, the GPS is not wandering. It's not running away. It's kind of meandering. And so my latest theory I'm using ChatGPT a lot these days to ask questions. It's surprisingly, ChatGPT does know a bit about ROS and IMUs and that sort of thing. So it is useful. But it mentioned to me, hey, you should check your timestamps and make sure. One critical thing is that if timestamps in the ROS system are not matched properly between your different sensors like GPS and an accelerometer or whatever, then you could have problems like this. Also, it mentions different things like covariance and essentially the error percentage. But anyway, this seems to be a difficult problem. I'm having to. I haven't checked those timestamps yet, but that's one B. And as far as the covariances or what the error, that's being generated by the GPS, and it seems to be reasonable. It's in it's in meters squared, and it was 81. So 81 would be 9 meters squared, right? And so that seems like a reasonable value to be essentially your GPS could be 9 meters off, essentially. It seems a little high, but that's just I'm getting that indoors and whatever, so that it's not a terribly wrong value.
So
anyway,
what are we supposed to see when it's running correctly?
Well, okay. Oh, I should have done that video. Well, what I can do is what I've been doing to sort of troubleshoot this is putting in a fake GPS. A fake GPS is just a little program that repeats the same exact location over and over and over. So you would only see one dot here, okay? And then in that situation, this axis would also be still. It won't move. And so that's what you'd expect. You'd expect this map thing to move no more than the GPS is wandering, but not go off into infinity like this.
Does it keep going?
Makes sense?
Is it unbounded, or is it kind of like, but that's the map to ODOM?
It's mapped to ODOM. It's getting into hundreds and thousands of meters away.
Just sitting, so the robot's sitting
Robot is
still.
sitting
and this is
still.
the-
This is, and you can see the GPS is only going a few meters. It's not like, I mean, I'm only giving you 1 minute.
And are you feeding in zeros for everything else, for all of your gyro and accelerometer?
Well, I tried that. I fed in zeros for the accelerometer. The gyro was already coming out zeros.
It looks Brownian, doesn't it?
It looks like a fractal.
I think it is. I think it is probably.
Brownian? Oh, like
It's just kind of like a random walk.
Like watching a water molecule.
What a Brownian motion. I didn't know if that was truly random or if it's like,
Well, it's not random.
It's not random. It's hard to predict.
This might get deep real quick.
Anyway, that's all.
But your common filter has things built into it, like hidden variables like velocity and stuff like that.
Yes,
And
state
so-
variable.
And so it's kind of trying to like, well, if the GPS is going this way, I must have a velocity, right? So it might be things
It's,
like.
notice the pattern here. I've noticed this pattern where if you notice where the GPS is going, and notice that that line to the axis is kind of going in the opposite direction.
Yeah.
And I think that, so inside this is all, I don't want to get too deep, but the extended Kalman filter is where you pump all this data in. You're supposed to come up with a stable thing. That's a Ross standard. But a Kalman filter, I also eventually could give a lecture on that, hopefully, but if I'm smart enough. But a Kalman filter takes these different sensors that have disparate information with different error rates, and it tries to find the strengths of all of them together and give you a more stable thing. But to do that, it's got what's called an internal state, like a 17-dimension state, which includes, position, velocity, acceleration. And so it needs to, when it gets data in, it has this state that it needs to update regularly, and it sort of tries to predict where things are going in its internal state, and then brings in the real data and tries to correlate those together so that its internal state is affected by the real data, but it's also affected by the equation in the internal state. So if you have your settings wrong, your internal state could be way off, and that could cause a problem. And it's, and if your sensors are way off and you're telling the system that your sensors are very accurate, then it gets confused. So that's why it's very important to know how accurate are your sensors. Anyway.
When you mentioned more than 4 dimensions, X, Y, Z, and time.
It sounds difficult, but it's really just because it's just really position, orientation,
17 variables. That's all it means.
17 variables.
Yeah. Yeah.
Well, they call it
It's called dimension. But yeah, you're talking about this, the dimensionality of a space, but it's the dimensionality of a vector. So what?
It's a vector. It's a vector of numbers.
So if you say, well, I was here, then I was here, then I was here. So GPS is already giving you 6-dimensional or 4-dimensional. No, it's gonna be 4-dimensional. Sorry, 4. X, Y, Z.
X, Y, Z, and altitude.
And then, so what would the common filter say? Well, look, I think I'm here with X and Y and Z. And I think here's my velocity, Vx, Vy, Vz. And I think here's my acceleration, Vx, Vy, Vz. I think this is my rotation, theta x, whatever, y, z. So it adds up to 17.
It's just a bunch of variables that the common filter is keeping track of. That they call it, in a single word, it's the state. the state of your, the state of your robots in the world, which includes all those things. And it's trying to, and it's a very useful thing, but it can be tricky to get it working right if if there's something slightly wrong with your inputs or your data, or you're retired.
Hour-long presentations on common filters. So probably was from Greece. Spoke was himself.
Anyway, this is a work in progress. Oh, really? Could you understand? You couldn't understand it. I'm learning. I found a really good document from the and this educator. I think I might have mentioned him. I'm going to try to get him as a speaker here if I can. Automatic Addison. He's got these great educational robotics, and he has a whole web page for a common filter and ROS things, and he's explaining it at a more level that we could kind of grab. We have a hope of understanding. It's not like textbook avionics, level of avionics master's degree level. So that's what I'm going to read that more and more. And I haven't really gone, it's the unfortunate reality is to use a common filter, extended common, it has to be extended common filter for ROS, which is non-linear. Regular common filters for linear problems, extended is for the nonlinear. But anyway, seems like to me, to use a common filter, you actually have to read and understand a lot more about a common filter than you would like. Yeah, and unfortunately, maybe the reality, but like this guy, Automatic Addison, is spelling out like the minimum you need to know. And that's where I'm going to go for that. But
and what it comes down to is, what we had mentioned earlier in the day is that in simulation, everything is 100% perfect to 8 decimal places. I know exactly where that robot is in 3D space with perfect traction, right? But it's a little messy. So a fundamental issue is you have all these competing pieces of input. You have GPS, you have wheel addressing, you have command position, you have GPS, and you have your IMU, and all of them are dirty, right? Yeah. So with all of these dirty, imperfect pieces of information, what is a strategy to sort through the stuff and identify like the pattern and come up with as perfect as you can where you really are? So I don't know if it's the only one, but I'll give you an answer. Yeah, I really need to dig into that more for sure.
It's a fascinating area. I recommend it, but be warned. It can suck
there be dragons.
Yes, there be dragons. Perfect.
Okay. And Jim, to be clear, this is only in ROS with the extended common filter, right? It just doesn't show up if you're just looking at the GPS alone outside of ROS.
Yeah, I mean, well, if I look at the GPS on its own, I notice it wandering around just like you saw that graph.
Usually it goes all around like the circle. What's interesting about yours is it's always below the robot on that plot, which is, usually I'm used to seeing it just meander around like roughly in a circle. So,
yeah, I think it is doing that. I only showed you one capture and only for 1 minute, and it's indoors. So I think it's the GPS is doing fairly well on its own. It's not like a GPS problem per se. It's the integration in ROS, because I think I was showing you odometry GPS, which is the output from the navset transform, right, which is input to the the common filter. So you're seeing it before it goes into the common filter. And the other thing, the ODOM or map to ODOM is after the common filter. So that's sort of highlighting those little dots are reasonable, and they do go around the whole robot, but the axis that's darting away is not correct. Anyway, and I'm still also trying to understand how to configure a GPS. I finally figured out, looked it up in the NMEA language to change the baud rate and change the refresh rate. My GPS can go 10 hertz. So I've increased it to 10 hertz for good measure. Anyway, thanks.
Yeah, thank you, Jim.
All right, thank you.
Thanks, Alan.
All right, let me go ahead and share my screen. There are a couple of areas I want to touch on. The first one to just the tale of the go-to or the SLAM and navigation and GPS. I mentioned there's been a critical mass of people working on go-to projects. One of them that Brian and I have shared a link about is to run this nav2 SLAM stack directly on the go-to hardware. So we've talked a couple of times about setting up a SIG for the RoboMagellan competition, autonomous navigation to waypoint cones, touching them with scores assigned to each. Something that we can even toy with right outside the door in our new meeting area next month. But yeah, I expect between the two of us and possibly three, we'll see a lot more of that.
What, do you need their website? I thought you meant with Chuckosaurus. I may join eventually. I never know.
So in the previous month, it had irritated me that this was the $1,000 option for the charging dock for the Go2. Only available and only works on their $15,000 EDU version. And I'm like, this is sloppy. So so I ended up designing and 3D printing a Sony Aibo inspired version of a Go2 compatible dock. It's sitting on right here, and when everything's plugged in, it does charge. This one, I'm going to try not to use April tags. My current strategy that I haven't started yet is using some tech, maybe a YOLO model or something, to localize the dock in 3D space in the room, right? And then as I approach it, because the LiDAR is facing upside down and tilted at a 15-degree angle here. At a 15-degree angle, I think the full resolution LiDAR return should give me enough information to center when standing over the dock to be able to successfully hit the pad. So whereas the previous one, it looks to me like you could cross pad because the front two pads on the dog are positive, the rear two are negative. It looks like you could lay on this sideways. And all kinds of things that worry me a little bit. And on the new one, it's impossible to dock with it incorrectly. It's at an incline, the front feet are taller than the rear feet. So if I can just figure out how to center it, it should be possible to automatically dock it. I'm one step closer to having the dog operating 24/7 in my home for security, monitoring, or just all around annoying my bio dog.
They have it like get up and stretch every 2 hours.
Yeah. Gracie would really appreciate that. The moment it stands up, she's either barking at it or out in the backyard.
How's your dog bowl? That'd be really bad.
Yeah. The one video that I didn't link in beforehand. So this is the second calibration jig that I had set up to get the 100% 90 degrees. And there we go. That's a good shot. So you can see out of the box, I was within like 2 degrees, right? But using the jig and then fine tuning the offset code, you're able to get it. You're able to get it within, let's just call it a half a degree. You know, nothing's perfect. Real world's messy, but that is more than close enough for me. I'd also mention there's another guy that's doing 3D printed heads and, oh wait, no, sorry, that's a little more serious. 3D printed heads and tails for it. I think these are renders. But he's been doing a lot of fun. He's having fun with it, right? He's got some skill designing and printing. Let's see if I can find the video. So this is another one of his designs. And this was set up specifically to demonstrate the importance of having a breakaway head.
Yoga pad.
Oh. Right. So, you know, this is an extreme. You, of course, wouldn't do a handstand on purpose. This was just to demonstrate. But the dogs are unstable. You're falling off curves. Kids are kicking it off the inside, right? So, as you're planning on extending your quadruped platform, it is something important to keep in mind that it needs to be robust enough to survive a spill or two. The last thing on, I don't know how you're going to feel about this. It's just information. Is they're claiming Ukrainian troops are deploying the Go2 in combat for reconnaissance situations. So, two shots that I pulled from the relevant news article.
So they're using the camera and
they must be using camera and LiDAR for reconnaissance, building checkout or something. Even if this was the $15,000 version, which hopefully it's not, $2,000 is disposable money for these types of applications. So the combat robots and bomb disposable robots come in, I think, at 100K starting, and they're considered disposable-ish for obvious reasons. So whether it's true or it's just a promotional thing to show how advanced they are, I just thought I'd get that. I'd say this is a little bit more positive than the flamethrower videos.
That's just kind of silly.
Yeah, I'm not sure if I'm ready to trust a robot with a flamethrower yet. All right, that's all I got for this one.
Calibrate to the angle there. I mean, is that saved? And did you say that information is? Yeah, then it'll boot up to that. When it powers on, it will go to that.
Exactly. Yeah.
Whereas regular hobby servos, I have to keep it in my code, you know, for just a dumb servo. Yeah.
Yeah. And in the Stewart platform code for Arduino, as part of their setup, they have hand-tuned magic numbers for the milliseconds for their midpoint. So, and you look at their array of 6 for each of the 6 servos, it varies between like 1375 and 1490. So they just went in and figured out the pulse, and then they're doing the math based on that, assuming that's at 90 degrees. So, but for any modern projects, if you're working on something and you're thinking about using QWM servos, talk to me. I'm pretty sure I can talk you into spending a few more bucks per servo for like a full serial bus servo.
Serial bus servos, They're not that much more, really.
Not that much more. They're really super strong. They're programmable. They're a lot more accurate. You get live position, acceleration, and speed feedback, so you can do all kinds of fun stuff.
And they're strong.
Yeah.
Good. Yeah. Good.
Thank you, Alan. Next, Jess.
Well, you've already convinced me to switch. Because so I brought 3 things because I brought nothing last time and I felt bad. So I bring 3 things today. This is a Star Wars droid that I made, that I designed. I found a drawing of him online, and someone like just drew fan art of him, and then I built him just fully off that image. He's normally covered up, but I figured I'm not going to cover him up because that's the point of this. And Alan, the reason why I asked to play with this is because I have a very similar linkage in the head of this guy. But instead of having them sideways, I have my motors rotated 90 degrees. So I have one going this way, and then one going this way and this way. So I have 3, which lets the head on this go straight up and down. And I can tilt it and nod.
Okay, so that's a 3-axis Stewart. Yeah.
Yeah. I didn't know that's what it was.
I want to get a closer look at that. All right.
I did super similar too. I used the tie rods as well. I mounted mine a little differently. I like how you did yours so much better. And I just have another motor for spinning this. But I did this linkage because I saw a video of like the clear like tables that have like you put a ping pong on it and it like bounces the ping pong ball. A lot of them we used 4, so like just 90 degrees apart. But this is so small in here that I couldn't really fit the 4, so I had like
three points to final play, and 3 is perfect.
It's fine. Yeah, the only problem that I've been having, which is an easy fix, but it's just not on high on my to-do list on this guy, is the orientation of the servos is 2 here and 1 here. But because the whole robot is angled back, and because this has a weight and this is an aluminum Lazy Susan, which also adds weight, there's a lot of load on this back servo, and I melted through a servo horn at one point and had to replace the servo. So the solution the night before my convention was I turn off the servos when I'm not using it, and then I re-engage them when I'm using it. But the real solution would probably be to just rotate that whole motor plate, 1/8 servo plate 180. So I have 2 servos back here and 1 servo up here. I think that would fully solve it. It also moves some of the geometry around, so there's less scraping here, which is a whole fun problem that it has. But yeah, this guy's mostly 3D printed. I did most of him last summer, between maybe June and September. I met Walter at Long Beach Comic-Con with this guy, but I didn't have him working. I almost didn't go because I was like, I wanted him to work. But I'm so glad I went. It's kind of like the butterfly effect to me being here, I guess, and a lot of other stuff. So yeah, I think I'm kind of done working on him for now though, because he works. I can bring him places. I can turn him on. I have the travel case for him. I've flown to Europe with him. TSA wasn't that scared of him, which was cool.
That must look amazing in an X-ray machine, though.
It looks pretty cool. I didn't look for it. I got pulled aside once, and they were like, honestly, it didn't trigger anything. We just have no clue what it is. We just want to like see what it is. Just fair enough. It's a strange thing, but yeah, it's 2 wheels. Just these 2 move, and then when this is on, it looks like to someone who's doesn't know much about robotics that it's not 2 wheels. It's just magically 1 wheel.
So that looks flexible. What material is that?
Just PLA.
Oh, there's enough give. Oh, nice.
Everything is PLA except here up is ASA because I'm scared of it melting. So, because I want to use him outside and I don't want him to. Yeah. Oh, yeah.
I've seen the letters. I haven't tried it yet.
It's like ABS but a higher UV resistance.
Okay. Okay. Does it work like ABS?
No, it prints much easier. But I think it was $30 a spool. I probably would use PETG instead next time. Because Walter's been using that on his, and he goes outside with his all the time. It's fine.
So PETG is almost as good, or pretty much.
Oh, but you can't post-process it, right? Like you can't sand it and paint it. And...
I've haven't really had problems with ASA at least. PETG, I'm sure. I mean, I hit it.
Yeah, let me know if your experience differs. I always thought it was a non-starter, but
what is Walter? Walter's I thought Walter.
He was post-processing PETG. But I haven't.
He is, yeah, because yeah, that's a whole rabbit hole of post-processing. After Long Beach Comic-Con last year, I stripped down all the paint off of all of them, off of everything I learned from everyone, and seeing how much better everyone else's look. Which is why this looks so much better than this, because this is the most recent stuff. But yeah, I guess I should move on because there's 2 other things to show. So one of the things I didn't build, so we'll start with the other thing I did. I have a friend who's starting a new robotics competition, and he asked me if during downtime I could build the DVD screensaver. So this is an X drive, it can strafe, and there's 8 ultrasonic sensors all around it. So this sits in the arena and just bounces around like the DVD screensaver logo. This changes colors. It's kind of annoying how much people like this, how much time I spent on it compared to something like that. But that's also kind of just how this stuff goes sometimes. So it's true. It's just running an Arduino Nano. It's just one, and these are just 2 terminal blocks. These are ultrasonics. So it knows for wait. Yeah, but a part of this arena is like this 45-degree piece. So I did a bunch of testing with ultrasonics and different orientations and settled on them being just at a 22.5-degree angle. So it can measure a wall 22.5 degrees apart or 45 at 22.5 degrees. The numbers I get don't mean anything, but I know when it's close. So okay. I don't care. That doesn't mean
we'll call that unitless.
Yeah, it's unitless. I'm really happy. The only problem I have with him is this battery connector sucks, and if it hits the wall in the wrong way, it disconnects for a second, and it's very unsatisfying. It comes back to life after a sec, but it's like the whole point of the fun of this is that it bounces off the stuff, and then it just kind of sadly sits there while the IMU recalibrates. But yeah, this guy's fun. He runs PID to keep him from doing this. Just real simple.
Yeah, so what's your cycle rate to go through all of your ultrasonics?
I do it every 60 milliseconds. Every 60 milliseconds I run through them all. I found some library for that, and then changed it a bunch to have timers on each one. Because I was having a problem where I hit a wall, and then this sensor would trigger multiple times and drove away as well. So I have 2 sets of like locks. Each sensor is locked for some amount of time. So you can't trigger again for, I think, like half a second. But then after one sensor is triggered, no other sensor can trigger for, I think, a quarter of a second. Because if it's in a corner of a wall and one's close, sometimes that was triggering and was doing some weird, unsatisfying movements.
You want it to go right away from the closest point. Right?
Yeah, and then there's different things depending on which side is hit. So if it hits this side, it will flip the Y direction. If it hits this, it'll flip the X direction. And if it's a diagonal, it'll flip both X and Y. So it bounces like hits the corner. Yeah. So yeah, we could run this later in the hallway probably. I'm sure it would work. And last thing I didn't build, but I had it, and I got it on Monday, and it was too cool not to bring. This is a chunk of Riptide, the battlebot. I was gifted this from the captain. Yeah, it's real heavy. I'm probably going to move it. I'm going to move this over here. Yeah, and then I'll bring it down. Just here, and then I can put this on the table. So yeah, it's 1-inch aluminum. And it's kind of crazy, like perspective this puts in, because this was one piece at one point. I could not tell you how this went together, or that this was flat. This got destroyed by a big horizontal spinner. It hit this chunk out. Yeah, it's pretty brutal. This is stuck in there now. There's a screw that's never coming out right here. It's brutal. You guys can try to like play with this and pick it up later. It's really cool. It's 1-inch aluminum. I think it's 6061. Titanium drive shafts for wheels. That's permanently stuck in there too. So that was a part of this. Bearings kind of suck. Yeah, it's pretty cool. So this was the inner channel. So there was a piece here, and there was another one here to protect all the wheels, and this whole assembly mirrored on this side. So the weapon shaft was attached right here. It was a 50mm titanium shaft that would go all the way across. Yeah, it's pretty cool. How far did they get? They go very far. Yeah. They got knocked out because the main driver got COVID and someone else had to drive it for the first time. Oh. And it's tough to drive something that's going like 15 miles an hour when you've never driven something like that before. And when you turn, it gyros and it's all strange to drive. But I think the really cool thing about it is on the other side. So the name of current battlebots is of winning is just longevity. Like it's not really about hitting hard anymore. It's about need to survive the entirety of the match. So teams, I don't really know when teams have started doing this, but it's becoming more and more popular. It's called shock mounting. So if you had a motor directly attached to aluminum, we see that aluminum gets shredded. So there's only so much more weight you can add before you start with weight from like batteries or motors or your weapon, because these are weight limited to 250 pounds. So the drive motors would go in these pockets, but it like float in a very hard rubber that would be cast all around it. and there'd be a support on the back of the motor as well. So if it gets hit really hard, it'll be okay. It'll just wiggle a little bit. Weapon motor would go here, exact same thing. Rubber would get casted in there. Similar to how this is done, but the new wheels use a different process of vulcanizing rubber, which I don't fully understand, but it's much denser and tougher. So your wheels don't look like this after a match. Pretty sure this is just Delrin and aluminum, but the new ones are all magnesium, which are super cool. Yeah, this is too cool not to bring. You all should play with this because it's big, heavy stuff. It's really cool.
Guys are they spend a lot of money too.
Yeah, it gets very expensive.
Like
Because
sponsors and
yeah, and then all your spares are wasted after season because you're going to redesign stuff that fix it. So if you don't go through all your spares, then you have like robots worth of parts. Just yeah,
maybe education.
I think they try to sell it. But,
Yeah, so
like this is all signed by them.
yeah, they sell it for as a souvenir.
Yeah,
Even,
it's really cool to have stuff like this.
especially a beat up one.
Yeah, I mean, you can kind of see how it goes together, but you need a lot of imagination to see how exactly these are going together. Because if it was like this, I'm pretty sure you can kind of see it, but there's a lot of missing force. Like, yeah, really bad. Yeah.
Well, yeah, Walter still has one of his old ones from the, he was in BattleBots in like 2001 or
The first years, I think, yeah.
yeah, and it's the small, yeah, it has some relics.
Yeah. BattleBots then I think was more about hit once very hard and win. Just knockout. Just don't go longer than like 10 seconds. But now there's a weapon weight rules, weapon tip speed rules. They added more rules. Yeah, I think your weapon can be approaching 110 pounds. So they measure the tip speed of it. It can't be over 250 miles an hour.
It's a pretty high rate.
It's low compared to what robots were though. Apparently, yeah.
Oh, like Blendo or what was the first
Schematic.
Oh, those rotating drums, those go really fast.
That's basically what this was. It was a huge vertical spinner from all that spun the entire weight of the robot.
Those go really because the bigger the rotate or the propeller is, whatever, it's slower, right? It can't go quite as fast as those drums, those with the spikes on them and
like this had a 1-2 weapon. They call them meter bars. They're basically just a funky shape to get the center of mass still in line with this, so you don't get weird vibrations. But it's longer on one side and then wider and shorter on the back, so it's still all balanced. With the idea of you get more time to get energy up, momentum up in the weapon before you hit. Because if you have it like a grinding wheel, then you only get like the energy between tooth to tooth. With this, you get a full rotation of energy before it hits.
oh, the odd shaped.
Yeah. Interesting. Yeah. There's a bunch of different philosophies and weapons on. You hit once and hard, you hit grind away. You just go more defense and just don't even have a weapon.
They're all valid, but they all seem to be different. I've watched. Last I went to Robo Games with their BattleBot. They had that was the last BattleBot they saw in person.
This is from Riptide versus Bloodsport. I'm sure the pictures on. Yeah, Bloodsport was a big horizontal spinner. That's why the chokes are all this way, because it came in this way.
Yeah. Like from like a year ago or 2 years.
It's easier to do that.
Cool, thank you.
I think that's it for me. Yeah. Thanks.
All right, so Jeff, we'll connect afterwards. The serial bus turbos, among other benefits, have a temperature sensor and a temperature cutoff. So
Yeah.
they'll actually shut down before they melt.
That would have saved this guy. The night before convention, my solution was good enough though. Just disable all the servos though.
Okay, so next is Seth, and last Thomas after Seth.
Oh, Seth's got the Odyssey. What is it? Odyssey? Or what is it?
Steamdeck.
And so we're gonna try to get that onto the Zoom meeting.
You guys, can you hear me all right?
All of you have those?
Yep, yeah, you're next after Seth.
Okay, let me know.
Really cool. There we go.
Oh,
that's
Looks like a
So what you
basketball
did-
game.
okay,
so.
Good for robotic stuff. So we got foxglove installed so we can to control because we're doing robot RC cars. So we're going to be able to actually control them from the Steam Deck. So Brian actually found this. So there we go. So that's on foxglove, and then it'll output the joystick messages with different buttons and triggers.
Real quick, foxglove, you know what everyone knows that is. That's a plug-in system. So you can make each of these widgets, you can make your own widget. And someone had made this widget. And so that's what he's dealing with, is a plugin for foxglove.
So
it can handle the messages. You had to define the messages and that sort of thing, or
he'll tell you. But that's something
So-
okay, yeah.
we found this on GitHub, or he found it, and so problem was that it was kind of unfinished because like it looks like there's supposed to be analog triggers, but for some reason they didn't work as well as the D-pad. So I made my own fork, and so actually have it loaded up. So this is a modified version of that. Okay, so in this version, I fixed. Oh, I'll turn on keypad mode. Alright, so I fixed the analog triggers because before they weren't analog. I also fixed the pad.
What this does is it's like a Chrome extension, and Chrome has Gamepad API, so you can read Gamepad from Chrome. And it wasn't working, and so Seth fixed it all. But the idea is it reads all of this, and it's going to publish all this out to the Foxglove web bridge or whatever it's called. And now you can hook that into your ROS message, do all that other stuff. So it becomes both the Foxglove and the ROS.
so that way you can track it. You can track what's happening in Foxglove through the simulator, or well, yeah, simulating. Or
And the first thing is we're grabbing the joystick. That's the first thing. The second is you can, publish it out.
So you'll be down or with
But Foxglove is the benefit of Foxglove is the visualization mainly, or is it?
But it turns out here it's actually reading and publishing the joystick.
So it's also the whole route that the data is
Yeah.
coming from the hardware into the system.
And if you use this, you don't even have to have ROS on the
No
Steam Deck,
ROS.
but it'll still publish out and be usable.
Through the web.
Yeah, at the risk of sounding
Nice.
slightly hyperbolic, Foxglove is everything RViz wishes it should be.
Yeah.
It's really a modern replacement.
It's modernized.
In time.
Right?
Oh, very cool.
That is cool.
So the idea is we'll standardize on the Steam Deck and Foxglove as our dashboard. And so we can have some of our own components and then some of the pre-built components. So like if I want to put that map you just showed, I can have that same map with a base link to map, and I can have my GPS on here, or I can have my joystick tree or whatever else is like specific.
Yeah. The full ROS Go2 CT over WebRTC just over Wi-Fi. So it's the whole thing, right?
Yeah.
Nice.
WebRTC. Oh. Yeah, so then you don't need to you have to run like RViz on a native computer natively. You can just have a web browser.
Yeah, Foxglove is the 2020-ish version of the 1990s RViz. Like it's complete replacement. It's
Yeah.
everything RViz.
Yeah, I dabble with it a little bit because they really promote it well when you're using ROS. It says, "Do you want Foxglove?"
Oh, do they? Oh, good.
Oh, really? I haven't seen that.
Somewhere it caught my attention, and I was like, "Oh yeah, download it and get an account."
But I haven't really done much.
Oh yeah, it's a standalone. You don't have to do the cloud stuff. Like it's a free download. But a cloud component as well.
Oh, yeah,
You require an account for it, but
And it's really nice. So I like the MacBook, but MacBooks are crap for rocks. But I can run Foxglove on it, and it works just fine. So it's like I'm running RViz, but it's on my MacBook.
It's like, oh yeah, any computer that has a browser can use it.
Correct.
Yeah. That's nice.
And also it works with really any controller, not just the Steam Deck. So if you want to use this on really any computer, or even if you don't have that, there is. It's not quite working, but there is interactive mode or keyboard. If you don't.
So yeah, you could run this on your computer and just touch it on the screen.
Oh, I see. Yeah.
So this would work with a dog too.
oh yeah. Definitely have my attention.
You have
on here.
Oh, because it runs Android, we could run the Unitree Go2 app on it too.
Like a,
I haven't tried that, and it just runs.
Android app?
You could run Android apps on it.
oh, you have to install a thing, but it's like a one command and then it automatically installs everything.
Is it Android emulated?
It's a container.
Contains.
If I remember correctly, it's called Droid. Yeah.
Okay.
So
Is the system ARM based?
it's x86 64-bit.
Oh, it is.
Is it?
Oh, okay.
Cool.
It's really what, Arch or something?
Yeah, it's modified Arch Linux.
Arch.
Cool. Yeah. I mean, you can tab over to show them like you have a terminal and everything. Huh?
Is
Oh, you see the command line or the. This is just running Linux. It's just the straight up Linux on this thing.
Which one is Arch? Is that?
Oh, it's a flavor like.
Oh, that's like Ubuntu. Yeah, I haven't used that one.
Yeah, so here it is.
Maybe I'm confusing the A Arch. I thought A Arch was the Raspberry Pi.
Yeah, so it's got virtual keyboard on it, all that good stuff. If you want to do anything, really get a separate keyboard. So it's a little bit janky. That you.
But it worked.
Kind of works.
Works with USB keyboard.
Yeah.
Oh, just say the separate.
Yeah, if you really want to do anything with the keyboard, because you might be hacking onto this thing, and doing this on the screen is hard, so you get a Bluetooth keyboard, and now you're fine. Okay. So
It's a full system. Is that?
cool. Is that it?
I believe so.
Would someone post a link to this product?
Steam Deck?
Steam Deck.
Yeah, it's just type in the name Steam Deck. That's
Google
it.
Steam Deck, it's a pretty popular.
It's getting very
Yeah,
popular.
it's a gaming device.
Yeah.
Valve.
It's similar
Is it,
to,
does
yeah,
Valve?
yeah.
Does Valve make it or?
Yeah.
Yeah, and he'll send you a link to his repo, right?
Yeah. And it has the latest release also. So you should be
It's $400 for the 256 gigabyte,
Yeah, that's not
550 for the 512 gigabyte, which is OLED.
Yeah, get OLED.
Yeah,
OLED.
The Go2, they have a $300 controller, but it's just the joypads. You still have to stick your smartphone in the middle of it. It's $300 just for that.
Oh, you didn't, yeah, you're not buying
I didn't
that.
know.
Yeah, this is I think this is, I got this a while ago, but I think it's 250. And I think the upgraded one is like 350. This is so much cooler. 400.
Got a little more money.
play all sorts of stuff.
Did you?
Play games.
You can run Zoom.
Yeah, that's actually so cool. It looks so good.
Yeah, yeah.
Like the quality of it looks like unbelievable.
Yeah, it's bad. It's bright.
All right, Seth.
Thomas. Thomas, you're up.
Guys, I can barely hear you.
Okay, you're up, it's your turn.
Okay, it's my turn. All right. Can you see my screen? So we're looking at ChatGPT 4 Omni,
Okay.
and I wanted to see its capabilities of viewing cards and figuring out hands of cards, if it can play games by sight. And I've had some pretty good results with this. I'd say not perfect, but let's go. So I'm playing 5 card draw poker. And excuse my voice, I'm still a little sick. I've have a bit of laryngitis. This is my hand. What do you suggest I do? You've got a pretty strong hand. There with 4 aces and a jack. His hand is incredibly, almost unbeatable.
Your opponent don't have something that could for
The best move is to stay in the game. All right, that's fine. Let's move on. Now, of course, the ultimate idea is to do this with a program and have it look at hands when you ask it to, rather than upload it from this application. That's my second step that I'm going to be working towards. And so I've uploaded it. The hand is much weaker compared to the previous one. You have a pair of jacks, which is not bad, but the rest of your cards, 8, 2, and 3, are not helping much. Well, it kind of got those wrong, didn't it? It got the numbers right, but the suit wrong.
Hmm.
Oh, wait, maybe it did. It's just not giving me the red. Okay, 2 and 3. That's right. Oh, we've got it right then. All right, it's got all the cards right. I recommend keeping the pair of jacks and discarding the other 3 cards. All right, let's go another one. There's a couple pairs there. Let's see what it wants to do. Close to forming a straight. Keep the 9, 10, 10, and jack. Discard the 6. Do I have a 6 in there? I don't have a 6 in there. It had that. That's wrong.
It might be looking at that
Oh,
upside down
it's the
9,
upside down 9 there facing. It looks like a 6.
the very top card.
Oh, you're right. It doesn't know that it's upside down 9.
That's
Ah,
thing.
are you sure about those cards?
Yeah, see if you can prompt it to fix. So. Oh, there's no 6 there.
Yeah, it figured it out on the second try.
There you go. It's like if,
Keeping the 2 pairs and discarding the jack. Let's do this one more time.
now
This, of course, is the traditional royal flush. And these are not standard cards. You can see they're oversized, the letters.
Yeah.
Okay, you recognize it as a royal flush in spade. So, is it any good? Yes. Is it perfect? Hell no. It makes one mistake in probably 10 hands, which is not so good if you're playing. If it can't identify the cards, it's going to have a big problem if it thinks a 6 is a 9. I've been experimenting with GPT in all sorts of games, chess, checkers, and others. But more than anything else, I wanted to navigate, and that's another problem that I'm working on. I want to see if it can navigate by sight. Supposedly, it should be able to, I've done some preliminary tests. I've said, I positioned the camera in front of a door. I said, can we go straight? It said, no, there's a closed door. And that kind of logic. It works some of the time. Is it better than other methods like SLAM and such? No, I don't know. It might be work really well in combination with SLAM. But that's where I'm aiming for this. That's that demo. One other thing is I have a new laptop that I bought just this week. This is upside down. Yes, it's upside. No, it's upside down. It is upside down. All right. How about now? Come on, right yourself. Oh, there we go.
Colors.
There we go. This is a MSI GE68HX with a GeForce RTX 4060. My goal here is to run. My goal here is to run GPT for all or one of the other GPTs locally and see if it works well, because I want to be able to make my my AI portable, and I don't want to have to go online to open AI. And I'm hoping this has enough horsepower under the hood to run all the GPTs. Now I'm still downloading here. I just got the thing turned on this morning, and these aluminum models take forever to download. Has anyone else tried a gaming computer for AI, for generative AI?
Yes. Yeah. That's what I've been using, a laptop, Asus Tough Dash F15. It's now a year or two old, but.
Oh, all right. You had some good results with that, didn't you, Jim?
Yeah, this has 6 gigabytes of VRAM, and so it was pretty good. But now that the models have gotten so good, and with the quantization, you don't even need as powerful to get good results, like Mistral 7B.
Mistral 7B. I don't know if I'm.
Yeah, any of the 7 or 8 billion parameter models, you just need 6 or 5 gigabytes worth.
Yeah,
it's nice.
It's nice, but what does yours have, Thomas? Gigabytes of VRAM,
I'm trying to look it up.
But it's a 4 series.
Yeah, I'd have to look that up. I don't know all the
8, maybe 8.
8. You think it is?
Probably. Yeah. Anyway, you're in good shape. You'll be able to run, pretty good darn models in with the.
Yeah, I was using a high-end standard computer, and the wait times were 5 to 10 seconds sometimes per token, which was ridiculously slow.
That's CPU. That must have been CPU bound, not GPU.
Yeah, it had a GPU card, but it wasn't using it, obviously. So I bought this extra fast computer to bring along with me because I didn't want to rely on internet.
Yeah, I mean, but it won't be able to play poker like the one you just demonstrated. It won't be able to do that kind of stuff. It'll be lots of things that are still cool, but not that level.
Yeah, not visual processing, not yet anyway, right?
You could.
Are there any? There's no models that do visual processing that are downloadable at this point.
There are, right?
Sure.
Is there anything tracking? I haven't been in the
multimodal space.
There is some. Yeah, that's a good question. I think there are some multimodal ones that are starting in this.
But there was a 13 billion.
There was a 13
one
billion
that worked really well.
Quantization could go to. Yeah, you have. The thing is, this stuff's changing week by week. So I don't know.
It's changing pretty damn fast, Jim. You're right. So you're saying what was the multimodal model that you were talking about?
3.1
Or Llama 3 vision.
Llama 3. Yeah, Llama 3 has a lot of good stuff. And yeah,
Llama 3, which one was it?
That's the vision.
Llama 3 vision. We just hearing here.
Llama 3 Vision.
Yeah, well,
I'll have to look it up and see if I can run it. That's all.
if, I want to get back to AI and, finish this GPS garbage. So many things.
It's impossible to keep up, that's for sure.
I can't.
It's changing every week. You guys are right. That's about all I have. Thank you very much.
Thank you, Thomas. And every Thursday, Thomas has, almost every Thursday, there's a meeting with Martin Trippett usually comes and they talk about AI developments for an hour at 7 o'clock. But yeah, it's unfortunately my dinner time.
All right, so was the last show and tell. If there are any others, this is the beginning of open session, or you can just call it the meeting. You can stop the recording now. And see you guys.